Welcome to the Blender modeling course, an engaging exploration dedicated entirely to the art of 3D modeling. Whether you're taking your first steps into this exciting world or have some prior experience, this course is designed with simplicity in mind, guiding you through Blender's modeling tools. Starting off, we will go through things slowly, making sure everyone feels at ease with Blender's user-friendly setup. Then we will dive into the main part of this course, where we will learn the basics of modeling. Each concept will be broken down into straightforward steps. And through interactive activities, you will gradually become more proficient in using Blender's modeling tools. As we progress, the course stays focused on enhancing your modeling skills. We will explore various aspects of modeling, beginning with creating simple shapes and gradually advancing to more complex structures. The ultimate aim is to equip you with the skills needed to transform your creative ideas into vibrant 3D models. Come join us on this journey into the realm of Blender modeling, where simplicity and creativity blend seamlessly, making 3D modeling an enjoyable and attainable skill for everyone.
Welcome to the Blender modeling course. In this video, I will show you the basics of modeling, namely, how to select and move the geometry of an object. At first, select the object and enter the edit mode with a menu in the top left-hand corner. In the edit mode, you can see and edit the actual geometry of the object. Each face of this object has 4 points which form the whole geometry. Now, when you want to edit parts of this geometry, you should select some of these points. There are several methods in Blender to select geometry. The simplest method would be to click on the points. When you click on it, you select it. When you click on another point, you will select the other one, so the selection doesn't add by default. You should hold Shift while clicking if you want to select multiple points. By holding it, you can click, click, and click on all the points you want to select. You can see that faces get selected when every corner point of them is selected. You can click somewhere in the blank space if you want to deselect them. Another method would be to drag a selection rectangle. Hold down your left mouse button or press B to draw a selection rectangle. When you hold Shift while doing that, you can add selections over each other to select the points you didn't get with the first rectangle. A rectangle is not an appropriate method for this model because the points are on curved lines. My favorite selection method is circle selection. Press C to enter the circle selection. Then you see a circle around your cursor. It works like a brush. You can scroll up and down with your mouse wheel to change its size. And now you can paint your selection. Hold down your left mouse button and draw the selection. If you made a mistake, you erase selected points with the middle mouse button. It is a quick and dynamic way to select your geometry. With a right click, you leave this circle selection mode. The last essential selection method is the free draw selection. Hold down Control and hold your right mouse button. Now you can freely draw your selection around the points you want to select. And again, with a click in the empty space, you can deselect everything. So, now we come to the basic modeling itself. To move some points around, let's select them again. Now, with points selected, just like with objects, you can press G to grab them with your cursor. Now you can move your cursor to move the selected geometry around. And just like in the object mode, you can limit the movement on fixed axes. To limit the movement while moving something on the green Y-axis, press Y. Or press X to move only along the red X-axis. Or press Z to move it along the blue Z-axis. For example, if you want to make the top of the sphere a bit higher, you need to select the points up there. And then press G for grab and Z for the limitation to move it only on the Z axis. Then you can move it a bit up and apply it with a left click. You can enter and leave an edit mode by pressing Tab on your keyboard. Additional to just moving points with G, you can rotate points too if you select more than one. Just select the geometry and press R for rotation. Now you can move your cursor to rotate them a bit. And, of course, you can scale geometry too. Let's select the top points for that and move them a bit upwards. Now, with the hotkey S, you can scale them by their center. Like this, you can create such a plateau, for example. There is another way of moving points which is quite effective in many cases. Select one point and press G to move it. Now, you press G again. When you press double G while selecting a point, you can move it along connected edges. So it's not limited by axes, but the connected lines to other points. You can do this with several points at once too, but it can get imprecise sometimes. I'll show you another handy way of moving geometry. You can snap points to other points, which means they move to a similar location. Let's move the top point up and select the marks around it. Using a selection circle and then erasing the middle point with the middle mouse button is the easiest way to do that. Then at the top of the interface is a little magnet icon. This is the snapping tool. You need to enable it and change the target on the right to the vertex. Now, when we press G to move it, nothing happens. But when we go to a point with our cursor, we can see that it snaps to the top mark. At first, it is not practical, but we could limit it to the axis. So we can now press Z to limit the snapping movement only to the height. And now you can repeat that for the outer ring of that plateau. Select the points, press G and Z, and move your cursor to the target points. Now, I can show you an alternative selection method which suits this situation very well. You can select a whole loop of geometry. Just hold Alt and click on an edge, which is the line between 2 points. When you do that, the loop along this line will get selected. By doing it, you can quickly select the geometry along this sphere. Sometimes this is the best way of selecting geometry. Okay, after you've learned that tool, just Alt-click on the loop underneath the plateau, and then you can press G and Z to snap it to the geometry at the top. And now you can efficiently repeat that for some more loops. Alt-click on the curve, and then G and Z to snap it to the top. And again. And at the end, you can select the geometry. You move it to the top and as a whole upwards. Now let me rotate it a bit with the hotkey R. And like this, you can model a bullet or something like that out of a sphere. That's all for this video. Thank you for watching. Welcome to the Blender modeling course. In this video, I will talk about the loop cut, the extruding tool, and the inset tool. So, to see the actual geometry, we have to enter the edit mode. You can do that with the little menu in the top left-hand corner. Now we can see the object's vertices, edges, and faces. We are going to add new geometry with the loop cut tool. This tool cuts through the edges in a loop around the object. The shortcut to the loop cut tool is Ctrl-R. After you press on it, you can hover over the edges to see the preview of how the cut would look like when you clicked Now. While in this preview, you can scroll with your mouse wheel to increase and decrease the number of cuts you want to make. I want to make 4 cuts, so I click to accept the amount. Now I can move my pointer to select the position of the cuts, but you can right-click to cancel the movement and go with the default center position. Now you created a lot of new geometry connected to the former geometry. If you now want to select one of the loops, you can shift-click every point, but the fastest way is to hold Alt and click on a loop's edge. It's better visible when I turn on the X-ray mode. You can see that you can select the whole loop. When you have selected one loop, you can slide it along the geometry by pressing G twice. You can now slide your loop around. When you select more loops, you can do that all at once, but be careful where you slide your loops. when you slide it on the positions of other points like this, it will cause many problems in the future with this model. That would be a big mistake. When I move one point around, you can see that there are now 2 points at that position. But there is a good option you can toggle on. At the top right-hand corner of the viewport is a little checkbox for the auto merge. As long as you check this, you cannot put more than 1 point on a position. If you do that, they will merge to the same point automatically. Watch me sliding the loops into each other once more with the auto merge enabled. No problem. But let's disable that to be sure that no points disappear somehow. But there are more ways to merge points, not only automatically at the same position. To merge points, you have to select them, and then you can open the mesh menu and go to merge. Here you can see the different options and how you can merge them. The center, for example, merges them to a point at the center of them all. You can press M to open the merge menu as well. The options at first and at last will merge the points at the first or last points you selected. So when I select them just by mouse clicks, for example, I can choose the merging point with the order how I choose them. But you can also change the merging position with a 3D cursor. Just place it somewhere with Shift and right click and then select at cursor in the merging menu. Then your selected points will merge at the pointer. But you can also merge at the center and then move the single point. But the neatest and most handy method is to merge points very close to each other. To show it, I make the forbidden move and slide one edge loop into the other to put them in the same position. And to complete the chaos, I slide the other into that. So this is quite a mess I produced here now. But here comes the super quick fix. Just press M and select Merge by Distance. You can see at the bottom, removed 12 vertices because they were too close to other vertices. And this loop is not overlaid with other ones. That is very convenient because these double points can happen simply by mistake. Let's slide that way with auto merge to remove also that last loop. Now we come to the extruding tool. At first, let me modify this geometry a bit and shape it like a simplified barn. Just some loop cuts to create more geometry and move the roof a bit upwards. Then, I want to create 2 more loop cuts in the other direction. I'm slightly changing its position and size to get some small faces. Then I select one face and press E to extrude. By pressing E, you create a copy of that face you selected, connected to the former face. Now you can move your pointer and move the new face at a 90-degree angle away, called along the normal vector. The normal vector is a vector that points straight away from your face. You can do that over and over. So, if I want to create something like a chimney, it would be better to extrude this face not along the normal vector of the face, but straight upwards along the Z-axis. That's possible too. Just press E to extrude it again, and then in the extrude mode, you press any axis, so X, Y, or Z. Then you disable the vector direction and have complete control. Now you can press Z to extrude the face along the Z-axis. We created now something like a chimney that looks directly upwards. To continue with the chimney modeling, we can use the last tool I will show in this video. It's the Inset tool. It is similar to the Extrude tool because it creates a new face out of an existing one. But with the Inset, the face stays in the same place and is just rescaled. For the Inset, you press I, then you can choose the scale of the new face. So, for the chimney, let's choose a thick wall, so make the face smaller. So we want to extrude the new smaller face again, but inside the little house. I activate the X-ray mode at the top right-hand corner to see it better. So again, press E to extrude, X, Y, or Z to cancel the direction, and Z again to limit the extrude on the Z axis. Now to show you how similar the Inset and the Extrude are, I am going to make an inset with the Extrude tool. At first, I create another chimney thing. You can see that something was not right because I still had the other chimney inside selected. You always need to take care of what you're selecting while modeling. So again, extrude that little chimney, and then I extrude the top face of that. Now I could pull out the extruded face like usual, but if I do a right click, the extruded face snaps to the position of the former face. So, there are now two faces in the same position. And then I can press S to scale the face down, and it's basically like an inset. I can extrude this face down like the other side, and I created this chimney thing without an inset, only with extrudes. By the way, you can extrude and inset multiple faces at once. You have to select them. Then you can inset and extrude them like this. That's all for this video. Thank you for watching. Welcome to another video of the Blender modeling course. In this video, I want to discuss a crucial topic in 3D, namely the normal vectors. A normal vector is a line that points away from something. For example, a face normal vector is a line that aims at a 90-degree angle straight from a face. Let me quickly model a little arrow to show a face vector. You can see that it sits in the center of the side, and it always looks away from the face. The arrow points away from the facet no matter how I rotate it. This arrow is called the normal vector of a face, or short, normal. This normal is very important for working with 3D and is used for many things. You can look at the normals of an object anytime by just opening the overlay menu at the top right-hand corner. You have to be in edit mode for that. There at the bottom, you see the different normals to display. The third one is the face normals. When enabled, you can see the normals displayed as blue lines, but on a cube, it doesn't look very spectacular. Let's add a sphere with many faces and look at that in the edit mode. Here you can see the normals are very good. It looks like a spiky hedgehog having faces looking in different directions. And when I select a face and move it around, you can see that the face normals of the connected faces are changing the angle because they are always pointing away from their face. Let's delete the cube and reduce the displayed length to see everything better. As I said, the normals are very important for 3D. I already talked about the extrude tool. It works with the normals as well. When you extrude a face, you extrude it along its facet normal. And with Alt-S, you can move a face along its face normal. It was just an example to show you where you need the face normals. Another significant use case for the normals is shading. What shading means is to give the pixels on the object the correct color. To make it easier, imagine that the faces that look in the light direction are brighter than the ones that look away from the light. Here the faces on the bottom right side are not as bright, and with the normal vector, the face knows the direction it looks in. So, here you see that every face has its brightness. It makes sense because every face has its direction, and it becomes brighter or darker depending on the angle. So when I want to make this sphere smooth like a plastic ball, I need a lot of faces. That is one option, but a more effective way is to leave the face count like that and interpolate the steps between the face normals on every pixel. You do this by changing the shading to smooth. Do a right click and select Shade Smooth. Then you will use the interpolated vertex normals, the normal vectors at the corner of the faces at the points. After selecting it, you see that it looks smooth now. That's because the few normals are now an orientation for many interpolated normals between them. At the edge, you still see that the outline is a bit edgy. That's because the geometry count didn't change. The geometry didn't get smoother or more, but the shading looks different. When you enable the shade flat again, you can see the actual geometry, just like before. Let me sketch a 2D view for a better understanding because this is very important. Here's the flat shading with the faces and their normals. Now, when you switch the view to smooth shading for every pixel, a new interpolated normal gets generated between them. So, then not every face has its brightness, but every pixel. It's very convenient without adding any geometry. Then it will look like this, just smooth. But there are some things to look out for as well. For example, when you have areas with edges like here, when I extrude the faces inside, the Blender will try to interpolate around the edge as it would be around curvature. Because one face looks to the right and the next face looks down, Blender interpolates the normals between them too. For this case, if you look in the object data properties, you have an auto smooth button with an angle under normals. When you enable that, you can tell Blender at which angle you want it to be flat and smooth. Everything above this angle will stay flat, even when it has smooth shades. Alright, so much for now about the normals. One last topic I will discuss is the joining of objects. When you want to join two or more objects, you should select them, and then press Ctrl and J, or go to the Object menu and pick Join. After I did that, you can see that my normals are wrong again. That's because my cube object didn't have the Auto Smooth enabled. Another thing to look for is that we shouldn't distort the transform. I said this before, but here you can see what happens when I scale the transform of the cube a bit before joining them. After I joined them, the ball didn't change its shape, but something happened unseen. If you look now at the transform, it's still deformed, but the ball won't get distorted when I attach it to the deformed cube object. You can see the damage when I separate the ball again from the object, that it becomes its object. The normal looking ball is the stretched scale, which means it got stretched the opposite way as the cube, because when I set the scale back to 1, 1, 1, it will change its shape. So beware of the transformation while you are joining things. The last thing I want to tell you about joining objects is modifiers. When I apply a modifier to the cube and join the ball to the cube object, it will become influenced by the same modifiers. It makes sense because I just added the geometry to the object with the modifier. It is the end of this course video. Thank you for watching, and see you in the next one. Welcome to another video of the Blender modeling course. In this modifier series, I will show some of the modifiers you can use to modify an object's geometry. This video will be about the array and the bevel modifier. Modifiers, in general, are a tool to modify the geometry of objects. In the edit mode, you can see the geometry, which means the object's points and how they connect to other marks. You can see all modifiers on the right displayed with a little blue wrench. You can click on Add Modifier to see the menu with all modifiers in Blender. At first, we'll look at the modifiers in the Generate category, which will add more geometry to the original existing. Right at the top of the Generate category, you can see the Array modifier. Click on it to add this modifier to your object. Now the modifier shows you a real-time preview of the object with the modifier on it. In this case, the Array modifier creates a copy of your object and places it next to your item. You can change the distance where the copy will be with the X, Y, or Z factor for the relative offset. This offset's name is relative because it takes the size of your object into the calculation for the distance. When I change the dimensions of my object by just moving a point, my item becomes wider. And because it is larger, the copy will move further away. The same happens when I rotate the geometry of my object in the edit mode. The item is more expanded when you calculate the cube diagonally instead of its regular edge length. Here you can see the width difference when you rotate the cube's geometry. Alright, let's go back to the regular unrotated cube. You can also increase the number of copies you want to create. You can do this with the count slider at the top. Now you have an array of cubes next to each other. You can also change the Y or Z value to move each copy a bit more to other directions. Now we'll come to another offset type. Instead of checking the relative offset, we'll look at the constant offset. It is the same thing, but the object's dimensions won't influence the copy's locations. When I rotate it or move some points, the position of the copies won't change because the value is just constant. Alright, now we come to the last offset type for this modifier. Uncheck the constant offset and check the object offset. Now nothing happens, and we don't have any sliders for this one. It's because another object controls this offset. So let's add another object. I'll add an empty object. Now click on your cube and select the empty object as the controller with the eyedropper. You can see that the difference between your original cube object and the position of the controller object is the offset. That's why there is no slider for this offset type. you move your controller object to define the offset for every copy. It's handy and dynamic to use. You can even rotate the controller object, and every copy will twist itself accordingly to the controller. Now we can build a little circular stair with this modifier. To do this, I'll make my cube smaller on the Z-axis in the edit mode, and then place the controller object above my item and rotate it a bit. Then I can increase the number of copies and easily create the stairway. Here you can see how powerful these modifiers can be, even the simple ones. But when I go to the edit mode, you can see that only my first object has a real geometry where I can see the points and everything. That's because the modifier shows just a preview of the newly generated geometry. If you want to apply the modifier, you won't be able to change it again, so you have to be sure you want to apply this geometry. To do that, you need to click on the little arrow in the modifier menu and apply. But as you can see, this is only possible in object mode. So let's go in the object mode and apply the modifier. Now you can see that every stair has its real geometry, and you can move them individually. Alright, so much for the array modifier. Now I'll show you another crucial thing, the bevel modifier. I'm creating a new cube and going again in the modifier menu. Here I select the second generate modifier, which is the bevel modifier. This modifier creates a slope on selected edges, which makes them more smooth and round. With the amount slider, you can set the distance or size of the angle. There are also different width types, which are methods to calculate the bevel size. The default is a distance you can choose, but for example, you can select a percentage to the next edge. But let's set it back to the default offset. You can increase the number of bevel slopes with the segment slider. It will make the edge rounder and smoother. You can see how the edge becomes more round as you increase it. You can make an edge super smooth without even enabling the soft shading. Of course, this needs a lot of geometry, but in some situations, usable. We can limit this angle to definite edges. Let me show you how. When I extrude this face to create this middle edge, you can see that sometimes it has a, and sometimes not when I scale the face. It is because the edge is limited to a certain angle. In this case, slants with 30 degrees and above are beveled. When I reduce this to 15 degrees, the angle of the edge has to be very flat to get beveled, as you can see. There are other methods to select edges to be beveled too. For example, you can select the edges you want to bevel to use the vertex group, and then go to the object data properties, the little green triangle below. There you can assign the points to a fixed group. Then you can select that group in the bevel modifier, and only these edges will be beveled. Another way would be to use the weight, for example. You can set the bevel weight for selected edges with the little side menu. You can open it with N. And when you increase that for the selection, you can see that the angle will increase for these. The last thing I'll show you is the profile. It is the shape of the edge. It is a linear line, but you could change that in the profile menu. You see, nothing changes when I do something here. That's because I only have one segment, and there is not much geometry to change. But when I increase the segment count, you can see that the bevel form will follow that graph. By this, you can change the shape if you want to. And that's so much for the bevel modifier. There is a lot to experiment with and explore. Thanks for watching. See you in the following video. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will talk about the Boolean modifier in Blender. We can use this modifier to create complex structures and surfaces effortlessly. So let's add the modifier to take a look at it. The modifier we added to this cube needs another mesh object to interact with it. So I add another smaller cube and put it slightly inside the first one. Now select the small cube with the eyedropper of the modifier. To show you better what's happening here, I will switch the display of the small cube to a wireframe. Now you can see what the modifier does. Currently the modifier subtracts the small cube from the large cube. It's the first possible function for the Boolean modifier. The second function is to join the small cube into the large cube and form a newly merged cube. You can see it here pretty well. And the third and last function is to define the volume where both objects are simultaneous. So what you can see here is the intersection of the objects. Alright, I've shown you the three functions of the Boolean modifier. But for further explanations, I will keep the difference option enabled because you can easily see what's happening. Furthermore, there are two options for the solver, which you mostly need to keep on exact. Sometimes it is too slow or causes some problems when you could try fast. But that is not too important. A bit more crucial are the solver options below. For example, you can find here the self-intersection checkbox, which won't do anything if you check it. That's because my small cube is so simple that it doesn't cause any problems yet. But when I now duplicate the geometry and place it in a way that intersects its geometry within the object, it will cause problems. Now it is rotated a bit and placed part inside and part outside of the other cube geometry. But it is still the same object. You may have noticed that the large cube disappeared in the meantime. That's because the Boolean modifier doesn't like to work with intersecting geometry. And now you can check the self-intersection checkbox to tell the modifier to do it anyway. You are free to modify the cutting form and everything will still work. The second checkbox is hole tolerant. It is not that important. Sometimes with some objects that have holes, the modifier won't do anything because you need completely closed mesh objects. With this checkbox, you can proceed anyway. Alright, that's all with the different options for this modifier so far. Currently, we see a preview of the geometry because we haven't applied the modifier yet. So let's apply the modifier to see the new actual geometry we created. Now you can go into the edit mode of the large cube and look at your cutout geometry. In terms of topology cleanness, I would describe this cutout as not very good, but it is not terrible. If you are not contented, you can undo the step and adjust the Boolean a bit. For further demonstration, I delete the second cube geometry. In general, if you use the Boolean modifier, you want to avoid creating points and edges too close to existing ones. Here I give you an example of a bad Boolean cut. This cut here is crummy because there are points very close to each other, and this will cause problems in the future. So let's undo this step and create a better cut. By the way, it is crucial that your object's transform has a scale of 1, 1, 1. Otherwise, it could destroy your Boolean modifier. This cut here is fine. Everything has enough space and the cleanup won't be much work. Because, in general, you have to clean up your Boolean cuts. Most of the time, it is not perfectly cut and the geometry fits well. Here I create another bad cut to show you what I meant by cleanup. I created a mess here with this cut, so I have to manually make this a good one by deleting, merging, and creating geometry. It can be more or less work depending on your objects. The entire cleanup workflow is a complete chapter with a lot to observe. There will be a separate video about this topic. For now, that's all for the Boolean video. You can now experiment with this tool. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I want to explain the cleanup process after a Boolean operation. Because when you do a Boolean operation like a cutout, in many cases it will harm the surface structure of your model. The cutout seems unnatural because Blender creates more or less random connections between points to make this cut possible. So, that's not a big problem if you clean up a bit after such an operation. I have got a cylinder here, which I want to cut. For that, I need another object to cut out of the cylinder. Be careful, if you are about to do a Boolean operation, you should make a copy of your object for backup. Even if you don't fail and everything works out fine, you will need it anyway for the cleanup in some cases. So, duplicate it in the same place and hide it so that it doesn't get in the way. So let's add a slightly smaller cube, which we want to cut out here. Then select the cylinder and add the Boolean modifier to it. Select the cube with the eyedropper of the modifier target. Then apply it to create the real new geometry. Just hide the cube, we won't need it anymore. Now you can go into the edit mode and look at your cylinder geometry. We've cut it, and it has a negative cube shape inside. You can see the newly created points here. This cut is not suitable because some edges are very close to each other. This situation can occur just because you cannot control everything about a cut. That would be too much effort. But that's not a big problem because you can roughly choose the position for the cut and clean up your model afterward. It depends on the model if it's better to plan the cut with effort or to make cleanup after. Now you may think everything looks alright, and where are all the problems I'm talking about constantly? Well, when you use flat shading, which is just actual face normals, everything is okay then. If you want your model to look like this, you don't have to clean up anything. The cleanup is necessary because the default normal interpolation has problems making it look right with the newly created geometry. But you can only see that in smooth shading, so let's switch the object's display to that. I think now it's not hard to see the problem this cut has caused. You can see it even better when I change the viewport display of this object to a very reflective matte cap. These are some preset display methods that are available in the solid viewport. With this very reflective red material, you can see the wrong normal interpolations very well. The first thing to do is enable the auto smooth in the object data properties. By this, only edges with a fixed angle are smooth. The others remain with the unproblematic flat display. After this little checkbox, you can see about 95% of the problematic areas are gone now. Most shading problems we can solve by telling the blender that you want to smooth only certain edge angles. But some problems remain around the edges of the square inset. You can see it pretty well in the bright reflection. Around the edge it is not straight but somehow broken or distorted. That's because Blender cannot accurately interpolate the normals for this area. It means that the pixels look in slightly different directions, making the light reflection appear wrong. The first approach to fix this is to increase the distance between edges and points. As mentioned before, here they are too close. So let's move them a bit. Select the points and press double G to move them along the edge more to the center. Now it's a bit better, but still recognizable. I will bevel them with Ctrl B because in the real world, 90-degree edges like this don't exist. When you create realistic models, you have to bevel almost every sharp edge. Now you can see that the edge has a reflection as well. It's good because it adds realism to the object. Alright, now we are going to fix the remaining normals issues. We need a copy of the cylinder we made at the beginning for that. Just select it and enable an auto smooth shading like on the other cylinder. We will steal its normals on some areas and use them to overwrite the normals on our broken cylinder. Since the areas without the cut are the same, we can use them on the dubious spots. So to do that, go to your broken cylinder and select the faces around the cut. If you made a bevel on the edges, don't select them either. Only choose the faces which are also on the new cylinder. Then you add a new vertex group in the object data properties. Let's name them Replace Faces and hit Assign to add those faces to this group. Then we add a modifier, the data transfer, in the first category right at the top. As the name indicates, we can transfer data from one object to another with this modifier. So now we select the source, the new cylinder we copied at the start. Then we select the desired faces called the Replace Faces vertex group. Then we want to overwrite the face corner data, so check this box. And as we want to have custom normals for our faces, select this bar. After that, you can select a method and how the custom faces are acquired, but mostly the last option, Project Face Interpolated, is just fine. After you've clicked on it, you can already see that the reflection around the cutout is fine now, but the bottom of our cylinder has changed also. That's because there was no buffer area between the face normals. We just replaced the bottom face of the cylinder. Sometimes we can fix it with another mapping method, but in this case, it is not a problem to keep it projected. We only have to create a bit of geometry between these areas to fix it. So do a loop cut between the cutout and the bottom of the cylinder. Due to the Boolean operation, the loop cut won't make a whole loop, but that's okay. After the cut, select the loop endpoints and press J. It connects them with the correct points in between. Now you have to exclude the extra faces we just created from the vertex group of the data transfer. After you've done that, you've finally finished. Now your cylinder's normals are fully repaired. But keep in mind, this data transfer is still live and active. If you move the copied cylinder, it will change the normals projected on the other cylinder. It means that it works only as long as the faces are exactly on each other's top. But of course, you don't have to keep them at the same spot forever. If you are happy with the result, you can save the new normals. You need to apply the data transfer modifier to save the new normals. Now you can move it around and look at the repaired model. This object is now fully fixed and ready to be rendered. Thanks for watching. See you in the following video. Welcome to another video of the Blender modeling course, namely the Modifier series. In this video, I will explain the manual approach to a Boolean cleanup. Because to understand how to clean up a Boolean operation, you need to understand what's happening and how to fix it manually. So, because we'll have a look at the face normals, let's switch at first to a reflective matte cap display to see it better. Then I want to cut a sphere out of this cube. So, let's add a sphere and take a look at it. Every object has flows of geometry in specific directions. On this sphere, you can see it pretty well. You have a geometry flow around the z-axis, which are many different sized circles. And on the other hand, you got a geometry flow from the top to the bottom. When you plan a Boolean operation, it is a good idea to work with the geometry flow to create the cut. Here in this case, these horizontal rings are all parallel to each other and the cube's surface. So in this case, it would be a good idea to keep this orientation. So let's scale the sphere a bit down and submerge it partially in the cube. It would be nice if we can move this one circle exactly on the cube's surface to work with and not against the geometry, because then you would not add any new geometry which isn't on the sphere. So then let's move the sphere downwards until the circle there will be precisely on the top cube surface. We do that with the snapping tool and change the target to face. Then press G for grab and Z to limit the movement on the Z-axis, which is the height. And then click on the cube surface to snap it on there. Don't forget to disable the snapping tool. Now the sphere is utterly placed to make the Boolean operation. We prepared it well, and everything will be neat. So, add the Boolean modifier to the cube and select the sphere as the target. Then apply the modifier and delete or hide the sphere. We won't need it anymore. The cut looks pretty good, but let's shade the object smooth to make the problems more visible. Make sure there are no double vertices at the cutout area because that can happen. So, this looks very fine. There are no geometry problems and the cutout is symmetrical and tidy. Now let's make an angle at the edge to reveal more potential problems because most of the time you will bevel sharp edges like this. And with an angle you can reveal problems with the normal interpolation because different oriented faces are coming into play. You can select the rim easily by holding Ctrl and clicking Sum at some rim points because this will pick the shortest path between them. Then create a slight edge with Ctrl B. So now when we look at the reflection of the top surface, you can spot some errors here. As you can see, something isn't right in the rim area. There is a difference between the reflection we expect and how it is. We expect a closer reflection, but it bends away from the rim edge. It's because there is a problem with the interpolation between the edge or face directions. To explain this, I will look at the surface a bit closer. Here you can see in which directions the faces of this part are looking. The top surface looks straight upwards and the bevel faces look continuously more to the left. Blender now interpolates between these directions because you only have 4 different directions. But you want hundreds of different pixel colors or brightnesses because otherwise it won't look smooth. And the problem here is that Blender already starts to interpolate the top face because we've turned away the next face on the left a bit. And we can fix this problem by adding a buffer area between the top face and the first bevel face. The buffer faces will look in the same direction as the big cube surface, which is just upwards. By this, we can force Blender to start the interpolation only at the rim itself. So let's do it so that you can see it. So we need to create another circle here connected to everything else. The easiest way would be to select the outer rim with the Control clicks, and then scale it a bit bigger. While doing this, you can see the normals interpolation happening in real time. After you've scaled the outer circle bigger, you do a loop cut along the one on the inner side. We created the necessary geometry, but it is still at the wrong height. We want it at the same height as the outer circle, so we snap it at the right height. For that, activate the snapping tool at the top and change the snapping target to a vertex. Then you press G for grab and Z to limit the movement on the Z axis, then click on one of the outer circle vertices. Now the circles are at the same height as you can see here. Now we got 2 rows of faces looking upwards, which means the outer part, which is the cube surface, looks upwards because it doesn't get interpolated because of the buffer area. And when we now look at our reflections, we may see that it looks perfect. No distorted reflections come from the interpolation of the face normals. I will show you another method of creating such a buffer zone if you can't do a loop cut. You can always build the faces just on your own without any tools. That's always an option if no tool can fit your needs. For that, I'll redo all the steps that the state is right before the Boolean operation. So, to build the top face by hand, I delete it by deleting these 2 edges, which connect the inner part with the corners. Now you can extrude the outer circle to create this buffer zone at the same height as before. Then you have your basic geometry set up and can start to build the flat top surface. Connect the corners with the closest points here by selecting them and pressing F. After that, you can create a face out of selected points. So, select these points and press F to create a face connected to all of these points. Then repeat that for the 3 other sides. Now it's perfectly fixed again without any tools. You can always build everything by hand, just as I said. Now you have your dented cube back. Thanks for watching. See you in the following video. Welcome to another tutorial of the Blender modeling course, namely the modifier series. In this video, I want to explain how to use the build and the decimate modifiers. So, let's add at first the build modifier to my object. Open the modifier menu and click on the build modifier. You may have noticed that the object disappeared. That's because the build modifier works with the timeline. This timeline is right at the bottom of the window. I've set my Blender to 24 frames per second, so 24 of these frames represent 1 second of animation time. And when I start to scroll through the timeline just by grabbing my marker, the objects begin to reappear. That's because the modifier deletes the object's geometry and starts to rebuild it over time. Just have a look at the modifier menu. Here you got the start frame, the frame number where the modifier starts to build it. And you got the length, which is the number of frames the modifier takes to rebuild all the faces. The modifier builds face by face. And because our cube here only has 6 faces, it looks weird because we've built the sides right away. So let's add more geometry to work with for our modifier. Go to the edit mode and select everything. Then do a right click and select subdivide. Then repeat that a couple of times until you have a lot of faces as geometry. When I'm starting to scroll through the timeline, you can see that the many faces are built in that 100 frames continuously. In the modifier menu, there is a little checkbox that says reversed when you check, that the whole process will be the other way around. The cube appears already built, and since then, you'll deconstruct it the same way as before. You can change that a bit, for example, the start frame to 20 and the length to 20. That means that from frames 1 through 19, nothing will happen. And from frames 20 through 40, the whole cube will be deconstructed with all the little faces. You may have noticed a pattern of the building process, so it is not randomized. If you want to have that randomized, you can check the little randomized checkbox in the modifier. Then the pattern will be randomized, and you can't see any structure here. It looks like the cube would dissolve. With the seed slider below, you can change the randomization pattern, so it will look a bit different from another seed value. But in general, this modifier is a bit clunky, and you don't have many options to handle it. I'd say you won't use it often because there are more controllable solutions in the Blender to do it. Alright, let's come to the following modifier, the decimate modifier. That one you will use more often, I guess, because it can help you to reduce the geometry of objects, which increases the performance of a scene. So let's add the modifier to our cube again. After I added it, nothing happened, and when I slid the ratio slider around, nothing changed. That's because you can't see the faces themselves. So let's go to the overlay menu at the top and enable the wireframe visibility so that you can see every face, even in object mode. Now, when I start to slide the ratio slider to the left, you can see the function of this modifier happening. The faces start to collapse into faces with fewer points, mostly triangles, but some quadrangles as well. You can check the triangulate box to verify that there are only triangles as new faces for this modifier. Now you can see pretty well how you can control the number of points and faces of this model. Sometimes a model has a too high resolution, and this method can reduce the point count without losing any actual detail. And you can check the symmetry checkbox with the selection for the axe you want to symmetrize. Sometimes you can't achieve it perfectly. The second method to do this with a modifier is the unsubdivide function. As the name suggests, you can undo a subdivision with this option. A subdivision halves every edge, which means it makes 4 faces out of 1. And when you increase the iterations of the unsubdivide, you can see exactly that happening. Uneven numbers create weird angles on the faces, which can look cool anyway, but the intended way is to use even numbers here. And when I use the 10th iteration of this method, I end up with the typical undivided cube from the beginning. It could be helpful sometimes. The third function is the planar option, which is a face reduction based on the angle of a face. But the problem with this cube is that all faces are perfectly flat, so I have to change that a little. To do that, I will move a point a bit around with the proportional editing option enabled. By this, the movement of the selected point will influence other marks in its proximity, which looks like I would pull out a bunch of dots. I only want to move them upwards, so I limit it to the Z-axis. After the movement, you can already see what this method does. The sides of the cube don't have any geometry at all anymore. That's because the modifier deletes every face that has less than 5 degrees to the neighbor. Here you can see the difference between when it's off to when it's on. And when I increase the angle limit, it will decimate the geometry of more and more areas because at some points they all exceed the threshold angle. You can play around with the angle to see which areas have which ones. And when the threshold is 0 degrees, nothing will change because no face would be affected. Optionally, you can decide which geometry should not be decimated and will always stay in place. That's called delimit, and you can choose the geometry differently. I will show you one method which is the easiest one, namely the sharp option. By this, you define the edges which would stay there no matter what the angle limit resembles. You have to select the edges you want, and after that you have to open the Edge menu at the top and pick Mark Sharp. Now you have marked the selected edges as sharp, displayed by a cyan color. And these marked edges are not affected by the decimate modifier when you select sharpness on the right. You should go back to the object mode if you want to see the modifier working. Now you can slide the angle limit back and forth and see that the faces get decimated by their angles like it was, but the selected edges are excluded from it and are staying like a border. Thanks for watching. See you in the following video. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I want to explain how to operate the edge split and the mask modifiers. Let's add the edge split modifier to our cube and see what happens. Open the modifier menu and select it. Well, nothing happened after we added it. The purpose of this modifier is to separate faces from each other when they exceed a certain threshold, but as you can see, the faces are still attached. To see what's going on here, I want to view the number of vertices and stuff like that. In other words, the statistics. You can enable that in the overlay menu at the top right-hand corner. Now you can see in the top left-hand corner object statistics when you are in its edit mode. The first number shows how many of the points you have selected. When we apply the edge split modifier and re-enter the edit mode, you can see that the number of points was increased by a factor of 3. And when you move the points away from the corner, you can also see that they detached from each other. That's why the number has increased, because now the faces are not connected, and every face has 4 vertices. You can move every point away from the corners to see what the cube would look like now. So the edge split modifier hasn't changed the appearance, but the geometrical structure of the object. I'm deleting the cube and adding a cylinder to show you a possible use case for this modifier. Then I add the edge split modifier to it. The cylinder has, other than the cube, areas with low angle faces like the sides and field with high angle faces like the top and bottom. When I now apply the modifier, only the top and bottom faces would be detached and isolated because they exceed the threshold of the 30 degrees defined in the modifier. When I now pull at the vertices, you can see exactly that. The top and bottom circular faces get disconnected from the rest, and the sides are like before. Maybe you can see that better from the top. The angle between the long faces on the side is slight, less than 30 degrees, and that's why they don't get disconnected. Only edges with a higher angle, like the threshold, get separated into two different ones, like the 90-degree angle of the top part to the side. Alright, so much for the edge split modifier. For the following modifier, I add another cube. The modifier in the list would be the geometry nodes modifier, but that is a whole topic, so we'll leave it out for now. So, add the mask modifier to the cube now. After you did that, the cube disappeared for some reason and is gone now. That's because the mask modifier hides certain areas of the cube, just like a mask in Photoshop. To show you its purpose, I'll subdivide my cube a few times to add some geometry. In the modifier menu, you can see the method of how you define the geometry you want to hide with the vertex group. You can set the vertex group in the object data properties. To do that, you have to select some faces, for example, and then assign them to a vertex group which you can add with the little plus on the right. Then you can name this vertex group. And after you set the group, you can select it in the modifier. And as you can see now, only the vertex group is visible. You can enable the modifier visibility while being in edit mode by clicking the little square icon at the top of the modifier. If you want to add more geometry to the existing vertex group, you have to select the new faces in this case. Then go to the vertex group and click Assign. Now we've added these vertices to this group. You can make the selection a bit smooth. It means you bevel the edges a bit. Not that useful most of the time, but mentionable. Alright, so much for the masking by vertex group. There is another method to mask the visibility of geometry, which is a bit different. The second category in this modifier is the armature option. An armature is like a skeleton with bones, and on these bones you can assign geometry, which then follows the motion of the bones. You can animate characters or robots like that. You can mask fixed geometry that is bound to specific bones with the help of armature masking. To show you the function, I will create a skeleton. If you don't know how to do that on your own, I'll demonstrate it in another video. But I create a single bone and extrude the tip a couple of times to create a string of bones. Then I just lay the geometry over the bone in the same position. And after that, I bind the geometry to the bone by parenting. Now when I move my bones in the pose mode, the geometry will follow the movement to a certain degree. As you can see, the geometry is bound to my armature now. The armature is an automatic modifier, as you can see here. Now I can select the armature with the eyedropper of the mask modifier. When I do that, my geometry disappears again. That's because now I only see the geometry of the selected bones, and I haven't picked a bone yet. To do that, I have to go to the pose mode, and here I can select certain bones. And there is my geometry. Here you can see which geometry is bound to which bone. You can also see that at the border area, these points are the last ones that move a tiny bit. When you leave the pose mode with the selected bones, the geometry stays like this. And when you deselect every bone again, no geometry will be seen, just like before. It's how to operate with a mask modifier. You can use it to isolate certain parts of your object if you want to work on them. Thanks for watching. See you in the following video. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will talk about the multi-resolution modifier. Generally, this modifier is partially effective, but some features are just too clunky to work with it. But let's add it to the object and go through it in detail. So the main thing you'll do with this modifier is to add subdivisions to your mesh. This will make it a bit smaller and increase its geometry. When you do this, you have different subdivision visibilities here at the top. you can select the subdivision count in the viewport where we are currently. But there is a specific number for the sculpting mode and the render. You can subdivide it multiple times but set only the render number here at 1. Then it would only look subdivided in the render, and you could work with a faster viewport with more performance because you only add the geometry in the render. You can click the subdivide button multiple times to keep subdividing the mesh. Every step saves here, and you could jump back and forth. It will look smoother and smoother, and the polygon count will increase exponentially. When I subdivide it first and click on Simple, you can see that it still gets subdivided and smoothed, but only on the faces. The particular edges keep sharp and don't get smoothed. And then when I press the linear button, the model itself doesn't change. It only subdivides its faces over and over again. It is the same as if you would subdivide it by hand a couple of times. You can see it pretty well if I apply the modifier and look at it in edit mode. The faces got more geometry with the subdivisions, but the outline didn't change. To show you a different function of this modifier, I add another object, like a monkey head. Then I apply the multi-resolution modifier to it and subdivide it a couple of times, and then I put on the modifier. Now I have a high-resolution monkey on which I add the multi-resolution modifier one more time. And now I can click unsubdivide until it gives me the error message. By this, I did the subdivision in reverse. I started with a high-resolution object and unsubdivided it until it was a low poly mesh, and commonly the subdivision steps save here as well. Alright, so much for the unsubdivided function. Let's go on with our cube here. The Delete Higher button deletes any saved subdivisions higher than the currently displayed ones. So if I subdivide my mesh a couple of times, it's very smooth, and when I now want to go back some steps because of performance issues, for example, I go back some steps. But if I want to delete these saved steps, I click Delete Higher and it will disappear. I would have to subdivide it again to regain these steps. The following function of this modifier is called Shape. It means to copy the pattern of a different object. So let's add a different object to see this. The two objects should have the same number of points, so we'll do a multi-resolution and apply the modifier. Then we're slightly changing the geometry, so it has a different look but the unchanging point count. Then select both with the first cube as the active object. Then click on Reshape. And here you can see why I would not recommend using this modifier for that. I've rearranged the points so that they match the point position of the second object. But the faces and edges aren't attached to the correct points. So this object got pretty much destroyed by the modifier now. There is an easier way to copy geometry from one object to another. I'll show you that later. But in general, I would only use this modifier for the subdivision function and to create displacement maps. I'll explain that in the video about displacement maps. With the Apply Base button, you can overwrite your base mesh with this modified, aka the broken geometry. But as I said, don't do it this way. One thing to mention, this changed geometry only at the first subdivision step. If I change this back to 0, it is the base mesh again. Then when I click Apply Base, this will look more like the first subdivision step. With the Save External, you can save the displacement data, but that's pretty much useless because there are better ways for that too. And at the Advanced tab, there are some general settings for the subdivisions, like quality and so on. These are only changeable if you haven't subdivided anything. So let's quickly create a monkey with this modifier because here is the last function to show you. Besides the quality, you can leave everything at a default here, but the little checkbox underneath Use Creases can be helpful. With a crease, you can decide which edge should stay sharp no matter what. To do that, you have to select the edges. After that, you open the side menu and increase the crease value of these edges. The hotkey for this is Shift-E. You can slide left and right to see a red color at the edge, indicating the crease value. When you now go to the object mode, where you can see the modifier visible, you can notice the sharp plateau at the top of the monkey's head. That's what a creased edge looks like when using a subdivision modifier. Alright, so much for the multi-resolution modifier itself. Now at the end, I'll show you a better way to copy geometry. For that, I add another object with a different geometry. Now let's have a look at the monkey head. It's got a geometry with the name Suzanne.002. When I now want to copy this geometry to the cube, I have to go to the cube's object data properties, which is the green triangle symbol. There at the top is its geometry located, and here you change it to Suzanne.002. Now they use the same geometry data, which means they will both change if I change one of them. They only look a bit different because one object has a modifier, so let's delete that. And if you now click on the little number on the right of the geometry name here, it will become its geometry and isolated from its twin. It means that we can change it now, and the other one won't change. That's the easiest way to copy geometry from one object to another. Thanks for watching. See you in the following video. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will talk about the remesh modifier. Click on the object and open the modifier menu to add the remesh modifier to it. After you'll do that, you will see something like a blob of your item. That's because the remesh modifier defines the new geometry based on the volume of your object. To explain it better, go to the blocks category to see it better. What you see here is how the Blender reads the volume of this monkey head. To make it a bit clearer, I copy the object and delete the modifier. You have to imagine it like this. Blender looks at your object in a three-dimensional grid and decides which boxes contain the item and which don't. Then every box containing the object gets the value 1, and the other boxes the value 0. By this, Blender defines the object volume as blocks. Then the object looks like a blocky version of the former element and coarse advanced geometry. For example, this block monkey is right next to it. You can change the box size with the octree depth value. The smaller the boxes are, the more detailed the volume approximation gets because more and more components we can detect from the small boxes. That's basically how this modifier works in general. The other categories work the same way. The only difference is that the cubes are connected there differently. For example, if I would connect the outer edges of these boxes, it'll form a smoother surface. And when I switch now the category to voxel, you can see what appearance this will have. In the voxel category, the boxes cohere smoothly to make them less blocky. You can change the voxel size in real time here. To show you that, I enable the modifier visibility in edit mode. Then you can see how the original monkey resembled. Then I slide the voxel size slider a bit, and you can see the voxels getting smaller and smaller and more details appearing on the surface. With a tiny voxel size, the shape is similar to the old monkey head, but the geometry count is too high here. We can see this in detail when I enabled the statistics in the overlay menu. The regular monkey head has around 500 vertices, and the remeshed version has about 140,000 vertices. That's quite an increase in geometry. When I apply the remesh modifier, the geometry of the monkey looks black. That's because the vertex density is so high it appears black with the view zoomed out. But when you need this small voxel size, there is a way to reduce the geometry. To show that, I enable the wireframe overlay so you can always see the geometry density. Now with the adaptivity slider, you can reduce the geometry of this remesh without losing too much detail. That's because Blender detects areas where mild geometry is needed, like flat areas, and reduces the density. Edges, hills, and other areas which require more points to display the needed detail remain with high point density. Now let's see the vertices count of the scene, which is only this object. Without adaptivity, it's around 140,000, which is pretty much for this object. And with a bit of adaptivity, it's around 30,000 vertices, so about 1/5. When I now disable the wireframe overlay, we can look at the surface of this remesh. It took some dents and lost some smoothness while Blender tried to find the less essential spots. As you can see now, it's always a game of trade-offs. Definite settings are better for fixed shapes or objects than others. But when you play a bit around when you want to remesh an object, you can find a good spot where you can continue the work. As I said, the other categories are very similar, but the only difference is that the volume boxes go together in distinctive ways. With the sharp remesh, the edges are more stinging and less smooth. With the smooth category, it looks more like the voxel type with rounder connections and fewer sharp points. The Remove Disconnected checkbox, which you got on some categories, is for cleaning up while remeshing. Sometimes there are areas where geometry isn't joined properly or isolated from the rest. With this checkbox, you can delete everything that isn't related to the most considerable chunk. So much for the functions of the modifier itself. Now I am going to show you another helpful use case for remeshing. For that, I delete the modifier for now. Then I go into the edit mode of this monkey and add a cube geometry to the object. You may notice that this is not another element because I added it in the edit mode of the monkey. It is just cube geometry. I added to the monkey geometry of this object. Then I deform the cube and stick it into the monkey's head. The geometry isn't connected, I just move the cube partially inside of the head. A curious thing happens when I add the remesh modifier to this object. The remesh modifier only reads the volume of the object. It means that the connections between points are irrelevant. And that's why the objects are connected here in the remesh modifier. So, when I apply the modifier and look at the object in the edit mode, you can see that they melted together. It's just because they touched their volume before. One last small thing concerning the remesh process. You can remesh this object without the modifier. There is a function in the object data properties for it too, but you cannot see the remesh in real time before applying the new geometry. That's the reason I would not recommend this if you can use the modifier instead. Thanks for watching. See you in the following video. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will talk about the screw modifier. Before I say something about it, let's add the modifier to this cube to see what happens. It somehow became circular, like a cylinder, but the geometry looks very broken now. When I rotate it around in the edit mode, there are a lot of face intersections, which breaks the geometry, but it becomes circular at every angle. That's because this modifier doesn't work with actual 3D mesh objects. It works with flat faces without any volume. So, let's delete some cube geometry to get only one face. Furthermore, the face should be around the x-axis by the default settings. You'll see why in a second. Now you can see what this modifier does. It extrudes the face continuously, but every extrude has a fixed angle so that, in the end, it will form a circle. And that's why it doesn't work with three-dimensional objects, because then much geometry would overlap. And now this 2D object doesn't have to be a single face. You can shape any surface you want. Just remember that this surface will extrude in a circle around the center. When I move the surface around, you can see how the radius changes because the position relative to the center changes. And you can see that if I move the surface to the top or bottom in this perspective, the circle gets thinner because the surface gets extruded at the same angle, no matter what its orientation to the center is. You would have to rotate the surface to prevent this. Now, after the general geometry explanation, let's get to the modifier options. The angle slider defines how far the faces get extruded. With 360 degrees, you got one full circle. With the screw slider, you can define how far the last extrude from the first surface. Combined with the angle slider, you can define how much the geometry should wrap around the center. Notice that the amount of geometry stays the same and doesn't increase while doing this. So the more you increase the angle, the less relative geometry you will have for the circle. But that's no problem. We will come to that in a minute. You can duplicate the angle and screw along the flow with the iteration slider. With the axis buttons, you can select the axis direction you want to extrude the surface. But for that, I would have to reposition the starting face here. For the next option, I need a different object, so I'm creating a simple plane. Now I click on the axis object eyedropper to select the other object. And now, this object is the new center instead of the origin of the screw object. When you enable the object screw checkbox, this object isn't just the rotation center, but also the screwed amount when you change the height. With this, you can change the modifier options more dynamically, and it may be easier to adjust. Now we come to the geometry amount. With the step slider, you can define the number of extruded faces. Here you can use a different number for the viewport and the render. And here again, you can see that a high angle value of the modifier requires a high step value. That's to keep it more circular and not that edgy. Alright, so much for the screw settings. Now I'll show you how you may use the screw to model circular objects like vases, cups, or alternative cylindrical objects. So let's say I want to model a vase. To start, I only need an object with just one vertex. So I add a plane and I cut out everything except this one point. Now I add the screw modifier to make a circle out of this one point because it gets extruded around the center. I open another viewport window so you can see what's happening here from another angle. Alright, now I extrude this point over and over to draw the silhouette or profile of my vase. And because this profile gets extruded in a circle, my vase shapes automatically. You can close the bottom, but you can also fix things like this afterward. I would keep it pretty low poly and edgy because when the rough model has an ending like this, I had a subdivision surface modifier to smooth the geometry analogous to the multi-resolution. Then the shape is finished, just like that. From there on, you can thicken the walls and everything, but that's up to you. Thanks for watching. See you in the following video. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will talk about the skin modifier. So let's apply the modifier on this cube to see what will happen. So, the cube became rounded and got a hole on every face. That's because the skin modifier creates geometry around the edges of your object. These are the lines that connect the vertices. So what you see here is the geometry located around the edges. With the branch smooth slider, you can adjust the shape of this geometry a bit. But now I want to show you what you can do with this modifier. Because this modifier creates geometry around lines, it is a suitable tool when you want to build grid shapes or something. Everything consists of thickened lines. Then you can use the skin modifier to create models like this grid. Also, there are symmetry checkboxes in the modifier. These are not that important, but with them, you can tell Blender which axes you want to have symmetrical faces on the newly created geometry. I switched the view to wireframe so that you can see the geometry of the skin. On basic shapes like this, symmetry adds anyway, so on simple models, you don't even need it. But if you have problems with the symmetry, you can try out these checkboxes. With the smooth shading checkbox, you can enable normals interpolation for the shading. For the Mark Loose button, you first have to select some points where you want to change the type and the geometry's generation at these points. Then when you click Mark Loose, you change the geometry generation here. That's only necessary when something is wrong with the skin, so you should fix it. It can happen when you create a closed line with the edges. When I change the corner point to Mark Loose, Blender connects the points in an odd way that the geometry looks very broken and intersects itself. Sometimes you have to mark some points as loose when you move the root around, but that's just problem fixing. The root is the vertex with the red dotted circle when you use the skin modifier. It's hard to see, but it is there. This core marks the main point of this whole construct and is very important if you want to create an armature. It is a skeleton to control the geometry. If you don't want to build an armature, the root is not that important, but edges not connected to it can cause problems with the skin modifier. You can also change the geometry's radius around the edges. For that, you have to select the definite vertices and can use the hotkey Ctrl-A to scale the radius for the selection. Alternatively, you can open the side menu with N or the little arrow next to the 3D widget. Here you can change the radius on two axes differently or at once to change the radius in both axes. If you want to set the radius on the axes to the same level, you can go to the modifier and click on Equalize Radii. Then the radius's X and Y values will become the same, namely the average of both. Now I'll show you how to use the skeleton for the geometry, called armature. For this, I only want a row of geometry with a start and an end, not the grid. So I extrude this string from a single point and add the skin modifier. Here is my model. The root is the bottommost vertex because I want my skeleton to have its base there. When I'm satisfied, I click Create Armature. Then a new object gets created, which is the armature. And my geometry has another modifier, which was added by this. The armature modifier binds the geometry to the armature. Now when I go to the pose mode of the armature object, I can move the bones around and the geometry goes with it. That's because the geometry bounded to the bones and gets influenced by the movement of the bones now. And my root is the center of all bones. You can see there is a hierarchy of bones. The root bone is the main bone, or the first bone, and then the other bones continuously influence the other bones connected to them. And by this, you can move them around in order. That is called a rig, and is a whole chapter of its own in CGI. But it's practical as you can directly generate a rig with the skin modifier. By this, you can nicely animate the limbs and branches of things. Alright, so much for the armature. When I apply the skin modifier, you can see that something is still happening with the geometry. That's because the geometry is still bound to the armature with the modifier. When you apply or delete this modifier, you'll get the free geometry on its own. So, now, at last, I'll show you how quickly you can create outstanding models with this modifier and simple models. I'm adding a torus object and opening the Add menu to reduce the geometry. By this, I get a low poly donut ring. Then I add the skin modifier to emphasize only the edges of this donut object. And then I keep scaling down the geometry's radius of the modifier with Ctrl A until they look like bars or something. And just by this, I got a pretty cool model which looks a bit like a wireframe out of metal. It's almost like a roller coaster track. After applying the modifier, I got the geometry of the many little bars here. And that's how you can easily create neat models with the skin modifier pretty fast. Thanks for watching. See you in the following video. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will talk about the solidify modifier. To see this modifier better, I delete some geometry of the sphere. Now the mesh is open and not closed anymore. It means I can see the adverse faces of this mesh. Because actually, a face has only one side. In Blender, you can see both sides. I enable the face orientation in the overlays to see the right and the wrong side. The blue side is the factual side, and the red is the back side. Alright, now we're ready to apply the solidify modifier. The modifier thickens the faces by extruding them along the face normals. You can adjust the extruded distance with the thickness slider. This value can be positive or negative. With the offset slider, you can change the position of the center for the extrusion. It means that you extrude outwards and inwards at the same time equally when it's on 0. When it's on 1, you can only extrude the new faces outwards, and if the offset is on -1, you can only extrude inwards. With the even thickness checkbox, you can level the thickness of the new geometry, as you might have guessed. Here it is harder to see because there aren't sharp edges, but you can see it changing a bit when I switch it back and forth. With the fill checkbox, you can disable the rim area of the geometry. Then you are left with only the top and bottom faces. And with the only rim checkbox, you disable the new outside faces but keep the original faces as well. Then, just like many other modifiers, this one has a vertex group limitation as well, that you can limit the solidify function only to definite faces. After selecting and assigning them to a vertex group, you can choose the group in the modifier. Then only the selected vertex group gets solidified, and its faces extrude. I think you won't use this function frequently because it's unnatural to extrude only certain areas with this modifier. After all, you can do it with just tools as well. Then with the flip checkbox, you can flip the front and back sides of the object. That's handy when for some reason this modifier messes with your normals. The high quality checkbox calculates the normals more precisely and thickens the faces more evenly. Nice to have, but seldomly necessary as well. I'll add some materials to this object to show the material functions. So I go to the Materials tab and add a green material to the object. Then on the second slot, I add a red material. And on the third slot, I add a yellow material to the object. And because the counting on the slots start with 0, I have green on slot 0, red on slot 1, and yellow on slot 2. Now I only have to disable the face orientation and make the material color visible by changing the viewport to Material Preview. Okay, currently the whole object has the material of slot number 0. But now I can define the material of the different areas of this modifier. When I change the material offset to 1, the extruded faces get the material of slot number 1. And I can change the material for the rim as well. When I now set this slider to 2, for example, it will get the material in slot number 2. You can freely change this back and forth as you wish. Let's disable the material visibility again. With edge data, you can add a crease value to certain edge areas separately. You can see the crease if you apply the modifier. It is a purple color on some of the edges. And there are 3 different areas. The inner edges are the original edges that got extruded with a modifier. The outer edges are the new faces, which are the extruded faces. And the rim edges are the edges between these. And at last, you can add a bevel value to the edges of the original faces. You can do all of that by hand later too, but sometimes it's just a bit easier to make these edge modifications in the modifier. With the thickness clamp, you can limit the extrusion to a certain amount. But as with many other sliders in Blender, you can overshoot this value by just typing in a number here. And the very last function is to directly assign certain areas of the solidified mesh to a vertex group. Just add a vertex group which you can select in the modifier as the target group for this area. After applying the modifier, we assign the area to that vertex group. You can test if you show the defined vertices of the group by selecting them. Alright, so much for the modifier. I'll show you one more thing to pick up on. As you know, the Solidify modifier extrudes the faces on the front side when the face orientation overlay is enabled, which is the blue side. Now I flip some faces of this plane to create a non-uniformly oriented surface. Sometimes it can happen in the modeling process by accident. Now when you add the Solidify modifier, you break the geometry of this mesh by extruding in different directions. So if your model shows a broken geometry like this with the Solidify modifier, watch out for the face orientation. That can solve many problems. Thanks for watching. See you in the following video. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will show you how to work with the subdivision surface and the triangulate modifier. Alright, let's add the subdivision surface modifier first. As I said in another video, this modifier is similar to the multi-resolution modifier. It increases the geometry count with the Catmull-Clark algorithm. I won't explain that in detail, but if you want, you can look it up to see how the new points are calculated. The smoothed increased geometry's result is a softer surface, which you can control with the original geometry. That's because it is calculated in real time from the original geometry. So you can move the old geometry like a controller to form the new geometry from this modifier. And when you accumulate points at one side, the object will have a higher geometry density there, which looks more squished. By this, it is precise and easy to control the behavior of the new geometry, how it is bent, squished, or bloated. You can see this effect even better when I increase the subdivision level to increase the geometry count and the smoothness. The viewport and render subdivision levels are separate here, so you can build it with fewer steps and render it with a very high poly count. With a high subdivision level, it's almost like a squishy ball you can play with. And of course, you can model your original geometry like before with inset faces and extrusions. When I want to create a tighter rim, like on a bottle opener or something like that, I have to add a loop cut to increase the geometry density in this area. Or you extrude this top a bit. That's the same result in the end. With an inset and an extrusion inside the object, you can create smooth caves, for example. Your original object will look blocky and sharp, but with the modifier, it becomes smooth and with a high poly count. By the way, the simple method with this modifier is just a subdivision method where the object's volume doesn't change, but the geometry count increases. And at the bottom of the modifier is a little advanced tab with some standard settings, which aren't that interesting. But the most interesting one is the Use Creases checkbox, because now I can show you how you can use creases to adjust the shape of your object a bit. A crease is an extra weight you can give certain corners to increase their influence on the geometry. After you've selected the edges of the wish, you open the right side menu with the little arrow or the hotkey N. There is then a mean crease slider. With this, you in and decrease the crease value of the selected edges. The crease value flashes with red color on the edges. And with this, you can create harder edges in the subdivision surface modifier without adding more geometry. Here you only move the current points. And now, back to the checkbox. With the Use Creases box, you can toggle the visibility of the creases on and off. And of course, when you apply the modifier, the new smooth geometry got realized but isn't controllable anymore, like before. Now we come to the Triangulate modifier. I want to add a sphere made of quads or faces with 4 points. I'm decreasing the geometry a bit for a better overview. Furthermore, I want to display the edges at any time, so I'm enabling the wireframe visibility in the overlay menu. Alright, it's time to add the Triangulate modifier to the sphere. So, at first, as you can see, the Triangulate modifier triangulates definite faces, which means it makes triangles out of them. With the quad method, you can select a definite way to do that. There are some differences, but that's not important for now. The n-gon method defines how to triangulate n-gons. These are faces with more than 4 points. But since the sphere only has quad faces and at the top and bottom only triangles, this can't be seen anyway. So let's create an n-gon to show you the different n-gon methods. So this face, instead of 2 by 4 points, has 6. By default, the setting is beauty, and it makes sense because usually this is more uniform and fits better most of the time. Then with the minimum vertices, you select the number of points a face needs to be triangulated with this modifier. 4 is the lowest value for that, but when you increase it, only the face or n-gon with 6 points is triangulated because its vertex count is higher than 5. Every face around it has 4 points, so when you in and decrease the value of this threshold, you can see the triangulation happening in the respective faces. I think you got it. So, after applying the modifier, you got an object with only triangles as faces. Now it looks a bit different than before, but there is something crucial about triangulated objects. They are a downgrade for modeling. When you model an object, you want to keep quad faces as long as possible. That's because some tools only work on quad faces. I had the same cube with quad faces again to show you one thing. With the hotkey Ctrl-R, I can add loop cuts to the model as always. Target an edge and create a loop cut along the crossed edges. But when you want to do a loop cut on the triangulated sphere, you won't be able to. It's because there is no loop anymore with the triangles now on the surface. So if you want to add new geometry along an edge, you should do it with a knife tool or similar operations. But loop cuts are now impossible. So keep your objects as quads, except you have a reason to do otherwise. Thanks for watching, and see you in the next video. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will show you how to work with the weld and the wireframe modifier. So let's add the weld modifier to the cube to see what will happen. Well, nothing happens. That's because the weld modifier is a specific modifier for one definite case. You can use the weld modifier to merge these points into a single point if you want to connect vertices that are situated close to each other. To see it better, I reduce the distance threshold for the point fusion. When I now keep moving these edges toward each other at a certain distance, the points will snap together into a single line. you can still see the original geometry moving while the modified geometry snaps together. For another example, I extrude a point to another point, and when I reach the threshold distance, these points snap together into a single point. When you change the mode from all to connected, this vertex merge only is applied on already connected points. When two points don't connect with an edge, they will not snap together when they are close. The same is for the rooftop. But when I now create a new face with the hotkey F while selecting the 4 points at the top, it becomes connected with the close points, and now they merge into a single point. You can also limit this to a definite vertex group. Select some points and assign them to a group, which you then select in the modifier. Only the rooftop gets merged, not the lower part with the extruded point. Even when I change the mode back to all, the points below won't merge. When I subdivide this edge to create a new point, this won't merge too. But when I now delete the vertex group on the modifier, everything can merge now again. Alright, so much for the weld modifier. I'll show you now another method for welding or merging close points, which you might use more often. It's not a modifier, but just a tool in Blender. To show that, I'll create this cube with a close pair of points at one corner. The tool is under a Mesh Merge by distance or with just the hotkey M in the Edit mode. After selecting it, you can control the merging distance with the little menu in the bottom left-hand corner. And that's the same thing as the modifier. Okay, now we'll come to the last modifier from the Generate category, which is the wireframe modifier. For that, I'll add just another cube to the scene and add the modifier to it. This modifier adds geometry to the edges of the object so that you can render the wireframe of an object. You can model your object as always, just that the geometry is only at the edges of the object. The geometry itself is pretty sharp, with not many faces. With the thickness slider, you can adjust the thickness of the wireframe. And with the offset slider, you can select on which side of the edges to add the geometry. The boundary checkbox does nothing yet because there are no unconnected edges currently. When you extrude one edge of this geometry, you can see that the wireframe is open and not closed like on the cube itself. And with a boundary checkbox, you can close these open areas. But there is a problem with this modifier. You can see it when I enable the face orientation in the overlays. You can see the red, the wrong face's side, which should be on the inner side of the mesh. It means the inner sides overlap the outer sides at some angles. It's a downside of this modifier. When you uncheck the Replace Original box, you disable the deletion of the original geometry. Then you can see the old faces. With the Even checkbox, you can make the wireframe's thickness everywhere. Otherwise, it would have a different thickness in some areas. When you enable it, the wireframe will be parallel everywhere due to the same thickness at every spot. And with the Relative checkbox, this modifier will change the offset depending on the surrounding geometry. The Crease Edges slider does nothing because it has to be used together with the Subdivision Surface modifier. Then you can crease the edges of the wireframe to give them more weight on the subdivision geometry, which results in harder edges. With the material offset, you can switch through the different materials if you got more than one assigned to the object. This material offset slider is present in some other modifiers too. They work all the same way. Like the vertex group option, you can limit the modifier to one definite group of vertices. Other modifiers have this option too. But this one has one more function, namely the factor slider, which is a smooth gradient to limit the thickness of everything except the group, which will always have the complete density. And after you've applied the modifier, the new geometry will realize. Now you have the new geometry set as vertices, edges, and faces. Thanks for watching, and see you in the next video. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will start with the deform category of the modifiers. When you open the modifier list in the third column, you can see the modifiers in this category. Firstly, I'll show you the armature and the cast modifier. Alright, let's begin with the armature. An armature is a structure to control the geometry like a skeleton. You have connected bones inside the geometry that influence the points assigned to the respective bone. This modifier is related to the process of rigging, and because of that, I'll give you a quick overview and no detailed explanation. So, to control some geometry with the skeleton, I need more geometry, so I quickly model something like a cactus or some other plant. It has a main body and a little arm. Once the modeling is complete, I have to add a bone. You can find that under armature. The root bone is the one to which everything else is connected. It's best to look at the model in the wireframe view to see where the geometry is. I now repeatedly extrude the bone's tip to cover the geometry of the cactus. The bone should be in the center of the geometry because I want to use it as the skeleton. I added an extra branch for the little arm somewhere in the middle. The geometry should have a little chain of bones when you've finished. Then you click the geometry and shift plus click the bones to pick both, with the armature as the active object. Then you open the object menu and go to Parent. You select Armature Deform with automatic weights. After that, the bones begin to influence your geometry. By doing this, Blender automatically creates a new armature modifier, so you can delete the old one. So, now the armature is the parent, and the geometry is the child, which means it follows the parent. But not only this, when you select the armature, you can go into pose mode, where you can move the bones isolated. You should enable the X-ray mode for that, to see everything. Now you can click on a bone and rotate it freely. They have a hierarchy that starts at the root bone, so if you move the second bone, everything attached to that will move too, and so on. And with this, you could rearrange the geometry or animate it like a little figure. But that's enough for the overview of the armature modifier. It is for binding the geometry to a skeleton, as you just saw. Let's delete everything and add a new cube for the cast modifier. When you add the modifier to it, nothing happens. It's so because this modification's purpose is to shape the geometry's form. In this case, Blender will shape this cube into a sphere, but nothing happens because the cube does not have enough geometry to display a sphere. So, go to the Edit mode and subdivide it many times to add more geometry. You can see the shape changing when I move the factor slider up and down. When you use factor 1, it will be a perfect sphere. And there is a notable difference between a normal sphere and one you can add in Blender. When you compare the geometry of these two, you can see that the flow of faces on the normal sphere has poles at the top and bottom. Everything is facing these poles. Eventually, a wider distribution of the cast sphere occurs, but as you can see, it has some corners from its former cubical shape, where the geometry is slightly denser. Alright, aside from the sphere shape, you can also form this cube into a cylinder with a flat top and bottom surface, and a cuboid shape, which it already is. Furthermore, you can change the sphere's radius and see how it is pushing from the inside on the faces of the cube. When you add another object, for example, an empty object, you can select that object with the eyedropper of the modifier. When you do that, this object becomes the new center of the sphere. With this, you can create interesting shapes and even animations if you animate the position of the controller object. When you assign some points to a vertex group, you can select this group in the modifier. Only the vertex group gets affected by this shape change. You can invert that selection with a little double-sided arrow in the vertex group. When you are content with the modifier, you can apply it to realize the geometry. Maybe one more thing to mention with the cast modifier. You can save the new shape as a shape key instead of applying it. When you do that, you can go to the Object Data Properties, and under Shape Keys, you'll find a Cast State Now. You can delete the modifier now. You don't need it anymore. When you now slide the value slider, you morph the shape to the saved form of the modifier. That's just if you want to work with shape keys, which are geometry's preserved states. Thanks for watching, and see you in the next video. Welcome to another video of the Blender modeling course, namely the Modifier series. In this video, I want to show you how to use the Curve and the Displace modifier. Let's add the Curve modifier to the cube. The purpose of the Curve modifier is to bend objects along a curve object. By this, you can create and animate cables, plants, ropes, and so on. To do that, we need a curve object like a path, so let's add one to the scene. You can reposition the curve's control points in its edit mode to form the path you want. Then you can select it with the eyedropper of the Curve modifier on the cube. Now you can see that when I move the cube in the positive X direction, it will follow the path with its geometry. Every other direction won't do that because the deform axis on the modifier is X. But pay attention to the position of the curve origin, and the cube origin has to be the same. If I move them around, they will get distorted pretty poorly. So to keep them in the same position, you can reposition them in the edit mode if you want to. Okay, since the positive X direction is the curve direction, you can scale the cube up in this direction to cover more of the path with the cube. Of course, you need more geometry to display the curvature. You can do that with some loop cuts. Now you can move the cube in the object mode along the deform axis, which is X, to snail through the path. Of course, you can use that for cool animations as well. Now I'll show you how to make a controllable cable, or something like that. At first, I need a circle to model the first segment of something like a circular chain. It's a cylinder with a small cylinder attached. Then I scale it down and place it at the start of the positive X axis, but in the edit mode because I want to keep the origin at the center. Then I add an array modifier to make many copies of the object, but not a certain number of copies. I want the copy number to fit a curve length, so I choose that and select the curve with the eyedropper. Now it influences the number of copies. And now, on this construct, I want to add the Curve modifier. Select the curve with the eyedropper to assign it to the path. And when you now move the curve, you have a procedural cable thing, which you can control just as you wish. You can extrude the path and move the points around, and the number of segments will automatically fit into the curve length. And everything is deformed by the path because we set up the modifier in the correct order. First, many copies along the x-axis, and then deform with the curve. You can increase the geometry again by making some loop cuts to the original segment if you are dissatisfied with the segment's position in the corners. Then the curve modifier has a sufficient amount of geometry. It will increase the round bending when the curve turns around. It is just a simple cable, but with this technique you can model many similar things. Alright, this was the quick cable tutorial. Now let's delete everything to come to the Displace modifier. For this, I want to add a simple plane because the Displacement modifier moves the faces along the normal vector, which is here only up and down. So let's add the Displace modifier to the plane. Of course, you can do displacement over the shader or geometry nodes, but I'll show you this modifier anyway. Alright, we need more geometry, so subdivide it a couple of times. For this modifier, we need a texture where we tell Blender which faces we want to move up. To be able to use a texture, we have to generate a new one in the Texture tab at the very bottom here. Then you can generate a new noise texture, like clouds for example. Now you see a cloudy image, which tells Blender how to move the faces. White areas move faces up, and black areas move faces down. The gray values in between are just less movement, so a neutral 0.5 gray means no action for a face. And now with the texture's parameters here, we can create some waves, for example. If that's enough for you, you may use this to experiment a little. There are some different patterns of noise to displace the surface. With the strength slider of the modifier, you can adjust the amount of displacement. And with the mid-level slider, you can adjust which value should be the center. So if you want black to be the neutral value and not gray, you can slide this to 0, for example. So when you have this on 0.5, it will displace up and down, but when it's on 0, it will only move the faces upwards. And here, in this modifier, you can also tell Blender to displace a definite vertex group, as you have seen in other modifiers. When you have selected and assigned some vertices to a group, you can pick this group in the modifier menu and only displace this group without affecting other points. That's what you can do with the displace modifier. Thanks for watching, and see you in the following video. We still have some fascinating things to do. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will show you how to work with the hook and the Laplacian deform modifier. At first, before we add a modifier, I want to model something like a small cactus to show an example of the usage of the Laplacian deform modifier. We'll start with the deform first because it's better to understand the example that way. I can model this cactus quickly with the skin and the subdivision modifier. So let's apply both modifiers from top to bottom, then realize the geometry. Okay, now we have the real cactus geometry, and on that, we add the Laplacian deform modifier. After we added the modifier, nothing happened. That's because we have to assign handles or anchors to use this modifier, which we can grab and pull on the geometry. That's how this modifier works. You have handles and pull on these to deform the mesh. You have to select the anchors where the geometry should either stay in place or should be pulled to stretch the rest. Assign that anchor vertices to a vertex group. You have to choose this group with the anchor weight selection after you have done that. When you now click on Bind, the handles will influence the mesh by stretching it. You have to enable the modifier visibility in edit mode to see it. Now you can move the anchor geometry to deform the mesh dependent on the geometry of the handles. That is a very efficient technique if you want to deform a mesh like this. This modification swiftly animates moving trees or other objects. The repeat slider in the modifier is there to adjust the precision of the Laplacian deform. The higher the slider is, the higher the iteration count to calculate this deformation. Higher numbers are slower to calculate but will mostly look better and smoother. Now you can play a bit around and deform the limbs of your object or character to see how it stretches. But there is a way to make this even better controllable. And here comes the second modifier of today's lesson into play, the hook modifier. Because with this modifier, you can control definite vertices of an object with another object. So let's add the hook modifier. Here you have to pay attention because the order is wrong here. We want to hook some vertices first and then calculate the Laplacian deform. So drag the hook modifier above the Laplace deform. For the hook modifier, we need another object as a controller to move the vertices of the cactus, so let's add an empty object as a controller. Place the empty object in a suitable spot on the limb you want to control. Then select it to the hook modifier as an object and select the anchor group as the vertex group. When you move the controller, it will influence all vertices of the object. That's not what we want. So we go to the edit mode of the cactus and select only the vertices that we want to move with this controller. After you've selected them, click on Assign in the hook modifier menu. Now when we try to move your empty again, we see the effect active. You can move the controller around the tip of the limb following the empty object. And because these vertices at the tip are an anchor for the Laplacian deform, it deforms the object in that cartoonish way. Of course, we can add a second controller for the other arm. Add another empty object. Then add another hook modifier and drag it again above the Laplacian deform. Then select the second empty object and the vertex group in that second hook modifier. Assign the tip of the left arm to the second hook modifier too. At this place, you can now rename the modifiers so that you know which arm is controlled by which hook. By the way, when you click on Select in the hook modifier, you can see which vertices are assigned to that modifier. And now, after all that, you got two controllers. You can now pretty freely deform this cactus and let him dance and wiggle and move around. You can influence the influence of hook with the strength slider. When you open the fall-off menu, there are several graphs to adjust the influence area around it and how it falls off with the distance to assigned vertices. But that's only working if you set a radius with that slider in which this fall-off is visible. That's sometimes useful if you are working with big anchor vertex groups. Here, it's not necessary to activate that. You would animate the controllers to animate the cactus, and that would be fine. But if you want to process the deformed cactus geometry in another way, you can apply the modifiers in the correct order from top to bottom to realize the geometry one more time. Then the controllers are useless, and the deformed cactus reflects the geometry. That's all for this video. Thank you for watching. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will show you how to work with the lattice deform and the mesh deform modifier. At first, I want to exchange the object for a torus because the deformations are better visible there. Then let's add the lattice modifier to the torus. So, the lattice modifier requires another object to deform the object. And you need a specific object for that, namely a lattice object. So let's add that to the scene. You can add that just like every other object over the Add menu. A lattice is a cube-shaped object you can use to deform another one. The lattice deform depends on several things. The proximity to the object geometry is the main factor, so when you want to deform an object, it's best to scale the lattice in the object mode that it's roughly the bounding box of the mesh object. So, it should fit tightly in the box. After you select the lattice object in the modifier, it influences the geometry. When you go into the edit mode of the lattice, you can move the points of the geometry around to reshape the lattice, and by doing this, it will deform the object bound to it. You can change the lattice geometry just like every other geometry. Experiment with rotating and moving vertices to see how it deforms the mesh. If the deformation is too rough, you can increase the resolution of the lattice in the object data properties. By this, it will get subdivided into defined axes, and it allows more precise deformations. Of course, this deformation method is not very precise, but you can form perfect shapes quickly with it. It's great for making little mistakes in perfectly built things, which often look artificial and digital. Alright, I'll show you another effect you can do with the lattice modifier. For that, I'll add a sphere and the lattice modifier. Additionally, I add a subdivision surface modifier for a smoother surface. Then I add the lattice object for the deformation. But here, instead of placing it around the object, I scale it down, so it is inside the sphere. Add some resolution to the lattice and select it in the modifier. After that, you can start to make some spikes pointing away from the lattice center. As you can see, this makes a hill on the sphere surface now. Because we scaled it down inside the object, it behaves like this now. By that, you can deform the surface and it looks like something is pushing it from the inside. After you've made some spikes on the lattice, you can rotate it in the object mode to move the deformation around the surface. You can go to the Select menu and select random vertices on the lattice if you want to intensify this effect. Then you can scale these random vertices up to have this random bent surface. You can now scale the lattice in the object mode up and down to see what will happen, or rotate it around, or move it around. As I said before, the proximity between the mesh and the lattice geometry plays an essential role in the deformation. The further away the lattice is, the less it will deform the geometry. Experimenting and playing around with this deformation tool can be very funny and enlightening. Alright, enough for the lattice deform now. Let's go on with the mesh deform now. Let's add the mesh deform modifier on the object. As the name already suggests, you need a mesh object for this modifier as a deform controller. So let's add a mesh object to the scene. I'll use a torus. For the mesh deform, the controller needs to touch the geometry of the object you want to distort. Only the geometry which touches the controller geometry this modifier deforms. Let's select the torus as the target object in the modifier menu. Then just hit bind to bind the sphere geometry which touches the torus geometry of the controller. Now you can see that the object mode is unaffected by this modifier. So moving the objects in the object mode has no effect. But when you move the geometry in the edit mode of the torus, you can see the modifier working. It's a bit better visible when I change the viewport visibility of the torus to bounds. Then it will be displayed as its bounding box. Now you can stretch the sphere geometry a bit around. You can add modifiers afterward, of course, as well to smooth the geometry. You can play around to shape something like a UFO shape, rotate the controller, and so on. When you're finished and are happy with the shape, you can apply it in the modifier menu to realize the geometry. That's how the mesh deform works. It's not so flexible to use, but still mentionable. That's all for this video. Thank you for watching. Welcome to another video of the Blender modeling course, namely the modifier series. In this video, I will show you the shrink wrap modifier. This modifier is very useful and can be pretty flexible for solving problems. So, at first, I want to add a sphere that I have something with more faces in the scene. Then let's add the shrink wrap modifier to our object. After that, select the cube as the target and see what happens. As you can see, the shrink wrap modifier is for moving the object's geometry to the surface of another one, like you wrap an object in tinfoil. In this wrap method, the sphere wraps around the nearest surface point, which means every point of the sphere looks for the nearest surface of the cube and moves there. Of course, since the sphere is a 3D body, it will get squeezed pretty much, so that's not so suitable for objects with volume. If you want, you can set an offset to the geometry to move it away from the surface. Alright, that was the nearest surface point method. The target normal project method is pretty similar, but is way smoother, and you could cover the edges and corners of an object. As you can see, since the edge was just the nearest surface, and so the geometry was stuck there. But it is very similar. You move the whole body to the surface and squeeze it very hard on the surface. The other method works almost the same way, except it searches explicitly for the nearest vertex, not the nearest surface. The nearest vertex is usually a corner of the cube, so I need to add some geometry to make it visible. So, when you move the sphere around, you can see that the geometry snaps to a grid on the cube. This grid is just the geometry of the cube. I can make the grid visible by enabling the wireframe visibility in the overlays. Then you can see where the geometry of the sphere snaps. By this, you can create appealing effects because the movement is then quite blocky and limited. But now we'll come to the particular and best method for the shrink wrap, the projection. With this method, you can project the geometry from the sphere to the cube. So all the faces shoot a ray along their face normals, and then they hit the cube, they move to the target surface. It looks like the sphere shoots a web or something like that on the cube. You can create effects like, for example, objects sealed in plastic. You can play a lot around with it to experiment with geometry. Alright, so you can limit the distance where the sphere tracks something to project on. When the limit is 0, it's just disabled. Then you can also limit the projection by the axis. When you enable definite axes here, the geometry will project on that axis. It can be handy when you project on objects that surround the sphere. The negative and positive checkbox decides in which direction to project the face. When you check the negative box, the faces will project along their back face. It means when the object is correct and the front side of the face is oriented outwards, the faces from the opposite side will be projected to the cube when you have checked the negative box. When you have the positive box checked, it will project the front of the faces, which is the default setting. For the face cull option, I have to enable the face orientation first so we can see the front in blue and back in red of the face. And I want to flip some of the faces so that we see the difference. To do that, I have to select some of the faces on the side. After that, I can flip their normals under Mesh, Normals, and Flip. Now you can see the back of these faces. You can now use the Face Cull option to decide which side of the face you can ignore in the projection. So when I enable the back face cull, it won't project the sphere on the backside of the cube's faces. These are the red faces. And I can reverse that, of course, when I choose front. Then it will only project on the backside of the faces. But when you keep it on off, it will project on any face. Furthermore, to the target surface, which is currently the cube, you can select another mark. So, you can have two targets to project on. It is the auxiliary target. Then, you can have multiple projections. So much for the theory. Now I'll show you an often used scenario where you can use the shrink wrap modifier. At first, I want a sphere shape with some bumps and hills, so I shape it roughly. After that, I add a subdivision surface modifier to smooth the geometry. After I've got my smooth, deformed sphere, I'm adding another spherical object, an icosphere. Now I can use the shrink wrap modifier to shape the icosphere like the deformed sphere. I take that shape for the icosphere if I project it from the inside to the deformed sphere surface. The icosphere has the shape of a deformed sphere, but it has not enough geometry to display all the details on the surface. It's better visible when I display the sphere as a wireframe to look through the surface. If we want to solve the problem of the lack of geometry, we should add enough geometry to the icosphere until it can display all the details. For that, you have to add a subdivision surface modifier to the icosphere. But it is crucial to have the subdivision surface modifier before the shrink wrap because we first want to add geometry to the icosphere and then project it on the massive sphere. Now you can subdivide it until it has enough geometry. When you are happy, you can apply the modifiers. You can see that I copied the other object by projecting the geometry to the surface from the inside. And because of this feature, this is a very useful and often used modifier for many geometry issues. That's all for this video. Thank you for watching.
Welcome to another video of the Blender modeling course, namely the modifier series. In this video I will show you the simple deform and the smooth modifier. At first, let's delete this cube and add a torus. That's because it has more geometry and has a hole in the center, which makes it very nice to look at when we deform it. Alright, so let's add the modifier to it, which is the simple deform modifier. You can already see that it got bent somehow. That's because we already got something here, the twist method. And we got an angle, the x-axis, which is the red line here. And you can see that you can twist it around the x-axis when you slide this angle slider up and down. You can push this to 360, but you can of course overshoot it like almost every slider in Blender, so then you can infinitely shoot it up. Maybe it has some limit, but then you can again overshoot it with just typing in numbers, and then you can break your geometry pretty much, as you can see. But the normal limit to it is the 360 mark. Alright, so as you can see, you can bend it or twist it in a radial motion around the x-axis, and of course you can change the axis to y, and then it's on this axis here. You can twist it just around. Alright, then you can bend it too, which looks like this. When you bend it, you can just squeeze it together on one or the other side. Notice we are on the green y-axis here, which means it's either the left or the right side. When we switch it to the red x-axis, then it's here or there. So this is the side squeezing here. When you click on the taper method, then you can squeeze it back and forth, or on the front and on the back end. And it's a different motion here. You squeeze it differently, but it's a squeezing motion as well, or a squeezing deform. And of course you can change the axis here too. It doesn't look that nice here because this torus has not that nice geometry on the x-axis, but you can push and pull the sides a bit in here. Alright, and the last one is the stretch. Let's change this to x back. The stretch stretches your object in a cartoonish way that you can squeeze the center and push the outer parts. By this you can create some rubber band effects or animations, and that's just the simple approach to it. In general, the simple deform, as you can see, is a very beginner-friendly thing because you have just one slider and you can animate or just set predefined shapes to your geometry, but it's not very flexible, so you are very, very limited to the deformations here. But you can change it a bit with the origin setting here. For this you need another object, so let's add an empty. And when you got that, you just select it with the eyedropper, and when you do this, let me just increase this value a bit, you can change the deformation by changing the origin point of the object. And by this you can have a better and dynamic effect on the modifier, but it's still limited. You can just have a bit more influence or a more controlled influence on it. But it's, yeah, it's not that flexible, but for starters, if you just want to deform it in this shape, squeeze it together in the center, you can use that. Alright, let's just delete this one, we won't need it. Alright, then you have your restrictions area here, which is basically a restriction from one side and the other side. Maybe let's look at the twist for that. So when we twist it with this limit slider, you can decide, as you can already see, this area now doesn't get twisted. It gets rotated, but not twisted. And you can slide this from left to right, and then you can slide the whole thing. So if you slide it all the way to the right, it doesn't get twisted at all, yeah, because it's a safe area where it's not twisted from the one side, and when you decrease the second value, it's a safe area from the other side, like this. And yeah, you have not that much geometry, that's why you can't see the twisting very good, but I think it's alright. If I add more geometry to it, you can see it better. Let's move this up. Alright, now you can see it a bit better. You have the safe areas, and you can just slide the twisted area back and forth. You can do shapes like this. Alright. So that's the simple deform. Now we come to the smooth modifier. So the smooth modifier, there are 3 different smooth modifiers, but they are very similar. So I will just show you the normal smooth modifier, and they're not complicated at all, but they work very similarly. So at first you have your shape here, but it's very smooth, yeah, because you can't see the smoothing effect because it's very smooth by default. So we just create some non-smooth areas like this spikes. They are not smooth at all. Oops, wrong direction. Like this. And now you have very unsmooth areas. And now you can choose a factor how hard you want to smooth these areas. I will just keep it at 0.5 for now. And then I can click on the repeat slider over and over again, or just slide it to left and right. You can go up until 30. And by this you can already see you're averaging the vertex position, the point position, to the points adjacent to it. So by this you move the points which are very far apart more to the points where they are together here. So this single point just moves down. Alright, and when you want to increase it, because you see it's very bumpy, it's not very smooth, it's way smoother than before, you can see the difference here, but it's very bumpy, and you can just increase the factor here. You have to be very, very sensitive because you can see, because you have 30 repeat steps here. Let's move this down to 20, and you can slide the slider here. When you hold shift, you have a very sensitive motion here. You can slide very little steps. Oops, I just overshoot it. You can slide very softly here and then increase this, and then it's almost like there were no spikes at all. So you can see the difference here when I switch this on. Then you can see that the spikes are basically gone. You can see the shape changed a bit. You can see this difference when I do that. With this icon here, you can display the modifier in the edit mode, and by this you can see how many volume you're losing. So here you can see the surface after the smoothing process, and here this silhouette is the torus surface before the smoothing. So by smoothing it, you can see it here, by smoothing you reduce the volume, because of course the points are moving together, and by this the shape gets smaller and smaller, but that's not that big deal. Alright, I mean later on you can always scale it up, yeah, for example. If you want to have it here, you can just scale the geometry up, and then after the scaling, so it's a bit too big from start, but after the smoothing, it's that the shape which you want. Alright, you got a vertex group here as well, of course. By this, you can just choose with your selection. Let's select this area here, this area. And you can smooth only this area if you want to, yeah? So if you want to leave all the spikes, but you only want to smooth this one spike, you can just select the areas you want to smooth, create a vertex group, assign it. So you assign the geometry to it, go to the modifiers, and then you just select the vertex group, and then only this area here gets smoothed. Yeah, you can see it here, disappearing in the surface. And when you want to add other spikes, for example, you want to smooth this as well, you can just select the area here, where you want to smooth it. It's nice to select a bit more than only the spike, because it's averaging on the other positions. Alright, that's okay. That's okay. And then you just assign this to the smoothing selection as well. And then it's gone as well. Yeah, I can see that. And now you have 2 spikes smoothed. Alright. That was the smooth modifier. Of course, you can apply it like this, and then it's gone. And by this, you can smooth the sharp areas of your objects. That's all for this video. Thank you and see you at the next one. Welcome to another video of the Blender modeling course, namely the modifier series. In this video I will show you the surface deform modifier. So at first let's add another object with more geometry, for example this icosphere, and subdivide it 2 times. And then we need another object as a cage. Let's choose that one. The cage or the deform controller can be bigger or smaller. I will just make this now smaller so it's on the inside. And toggle the X-ray mode that we can look inside there. So now let's choose the modifier here under deform, surface deform. And then you have to select your target, which is the cube in this case. And after you chose it, you can bind it or change the strength, but the strength you can change later, but you can't change the interpolation fall off, but it's alright at 4, it's just the smoothness of the pulling effect or of the influence. So let's bind it to the geometry, and now when you move this, you can already see that the geometry is bound to it. The cube is now the controller, like on the other deform modifiers as well. But on here, the focus is pretty much on the surface and not that much on the volume. Yeah, for example, you can pull this one in and you can see that it gets pulled in on the surface level. So here some vertices moving this way and this way, like you push in something out of cloth. Yeah, you can pretty nicely see that the surface is is deforming. And not the volume or other values. Yeah, it's really focused on the surface, so it gets pulled in here and then in there. Yeah, so that's how you can imagine it, like you pull something made out of cloth. That's pretty much how this works. And by this you can create something like a cushion. Yeah, as you can see, you can pull this in, move it a bit. Yeah. All I do is just move this one geometry point here. We can of course move these as well too a bit. And then this looks like a cushion which was pulled in, or you threw a little ball in there and then it got deformed like this. So you can do shapes like that. But now I show you an example what you can do with it, which is very nice. So for that I will just add a floor. And here I have to scale it up a bit. And then I want to add a plane, which will be my cloth piece I want to simulate, because I want to have a simulation animation to use for these surface deform. So I have my cloth here. I need a lot of geometry on that. Not a lot, but a bit like this. and maybe a bit bigger. And here I have my floor. On my floor, I want to have a collision that this object can hit that. And then I just want to rotate it a bit, that it's not super straight when it falls down. All right. And now I just add a cloth modifier. You don't have to know any of this, what I do now. I just want to make a little simulation. It's not important. All right, I will just simulate the falling down of this. That's all right. Maybe a bit. I just want to move it a bit, that it folds a bit more. All right, let's simulate that again. Like this. That's okay. And then I just bake the animation that it's saved and doesn't change. Alright, that's enough. Alright, so I now have my animation here. And what I can do now is, for example, add something else here. Yeah? For example, a torus. And just move that on this position of the cloth piece, like that. And then maybe I want to make the same dent in there as I did on the cloth piece. As you can see here, the line of the cloth, it's about the same. And now I can bound the surface deform. On this one, surface deform, choose the cloth. Alright, and now when I hit bind, now I did the same thing. Now the surface of this torus is bound to the surface of this cloth. And because the cloth is animated, because it was simulated, it will deform the torus like this would be simulated as well. So when I now hit play, you can see that the torus behaves like it's made out of cloth as well. So I can now just disable the plane. We can rename that we know what we have here. So I just hide the cloth. And now all you can see now is just the deformation modifier. So this surface now here mimics the surface from the simulated cloth. And by this, you can animate your objects, or you can simulate objects with other simulations. So it's not really simulated, it's just a copy of the simulation, because the simulation changed the surface of the cloth. And this torus just imitates that surface change from the simulation. And now when you have that, you have something like a dummy simulation. And when you now exchange this, for example, I want to add something else. Alright, and now I can again, maybe I need a bit more geometry on this, so I will just add a subdivision surface modifier on one and apply it like this. And now again, I use the surface deform on the cloth, bind it, and then let me just hide the torus and the cloth as well. And now when I hit play, you see this monkey head also copies the simulation animation, or the simulation surface change. And now you can see they all just behave like that. Yeah, so if I switch off the visibility of the modifier from the monkey head and the torus, they don't move, yeah, because they're not simulated. They only copy the motion of the surface. And by this is a very nice trick to just simulate something simple, a square cloth piece, and when you simulated that, you can copy basically that simulation to other objects with this surface deform. And for example, you can see that if I increase the strength, you see, it will just increases every motion. That's why it's not so good to use it for this. Because you see, so on one, it's just the copy of that simulation. And if I increase it, of course, the falling down process, or the falling down distance, of course, increases too, and then it's on here. So you have to keep it on one if you're copying simulations, because you want to copy them 100%. Except you want to copy them on, let's say, on 80% for any reason. Of course, you can do that as well. But this slider here is, for example, let me just delete this example. When you have, for example, a UV sphere like this, and then you have again your cage, and I add the surface deform and bind it. This motion here you can change with the strength modifier or strength slider. So let's put this on 3, and now the motion of the mesh here will be 3 times stronger than when I pull it. Yeah, you see that I pull it a bit and it will accelerate more, and it will even surpass this position. This is when you want to do something like this, but for copying a simulation, it's not that suitable, because you saw that you want to copy the simulation as it was. Yeah, and that was the surface deform modifier. It's nice for copying simulations mainly, or just create cloth-like surfaces without any issues of simulating cloth. You can just fake some cloth objects or something like that. But it's also nice, as you saw, for the simulation copy. That's all for this video. Thank you and see you at the next one. Welcome to another video of the Blender modeling course, namely the modifier series. In this video I will show you the warp modifier. So let's open the modifier menu, and when you hover over it you can read what the modifier does, and it says warp parts of a mesh to a new location in a very flexible way thanks to 2 specified objects. So let's just add that, and as the text said, you need 2 objects for this modifier. The first one is the controller, which geometry you want to warp or you want to change its location. And the second one is the target for the new location or the warp. So you can just use any object. I will use an empty because it's just a dummy object without geometry and you can see it pretty well. And because we need 2, I will just make a copy of it. So we have empty 1 and empty 2. You can call them, for example, controller, and for the second one, target. And then you can choose here either with the eyedropper. The from is the controller, and the second one you can just pick an object from the list, because I know what this object is because I named it. It's the target. And then you already have the modifier going. So you can't see anything because this is too far away from the geometry. You have to move it to a geometry, and you can see the geometry tries to, let's say, escape. So it tries to move to that target when you come near with the controller. And you can't see it that good because there is so less geometry on this, or so little. So let's just add some subdivisions, and then you can see it pretty well. So here is the controller and here is the target. And to see it better, you can change the display of the empty objects to, for example, a sphere. And then you can see which areas are affected and which not, because this sphere now is exactly the influence area. So you can see when you dip a bit in the surface, you can see this surface then gets warped. So by this you can control it pretty nice, and you can really see the controller range. And this one I want to have as a single arrow, because then I can see in which direction it's facing very good, because that's a bit important. It plays a role in the shape, but I will come to that in a second. So you can change here the controller position and here the target, and you can see I can move the target. I can even put it inside. Yeah, so don't be confused. The location is here. This is the target. The arrow is just the direction, so this isn't the target location, this one is, alright. So I can move inside of the object, and then I can make a dent on the inside. Okay, and now we come to the rotation, or why it's important to see the rotation of this thing here, because when you change it, you can see that it will kind of try to enter this target from behind. Yeah, so this one plays a role too, but it's, I would say, mainly the target. And for that is a setting as well. For example, here, preserve volume. You can see that. So if I just make this really hard like this, and when I check preserve volume, you will see that Blender tries to increase the volume a bit of this shape, because it gets very squeezed here and pulled away. So the volume really reduces here, and you can prevent that by hitting preserve volume, for example, and then it keeps its volume more. Alright, so I will just uncheck that for now. So the strength, pretty self-explaining, is the strength of the effect. And vertex group, as always, let me just select some areas here, like this. Create a vertex group, assign it, and select that. And then only this area here gets displaced. Or it's not displaced, but it's pretty similar. It's warped to the top. Alright. And then you can see only this area here is warped. And of course you can invert that group, that everything except this area gets warped. So you can see that here you have always a gap. Alright, so let's disable that. Then this is pretty nice, the fall off. This is basically how this shape looks. Yeah, this is the normal distribution, the smooth option here. And when you change that, for example, to sphere, then you will have this kind of shape here. Yeah, that one. It's more round. So when I just reduce this a bit, then you can see this is very round. And you have several of these, a root, which is a bit more pointy, but very similar to the sphere. Inverse square, it's even more pointier. And the sharp is very pointy. So if I move it here, so like this, and this is very pointy, like a rooftop of a church or something. So very pointy. And then you have a linear, which is basically like a triangle from the side with straight lines. And then you have a constant, which is just a plateau. And you have then additionally the curve, which is a custom fall off. You can choose, for example, like this or that or so on. Yeah, so you have to imagine this line here represents, in this case, that side. So if I want to have something like this, you just have to make the motion for the right side here, or the left in this case. And then you can define it how you want it to be. And then you have it like that. And then you can move it around. And you will have it like this. Alright, so this is a custom fall off. Let's just change it back to smooth. Alright, and then you have the radius, of course, too. When the radius is at 1, it's exactly as the display here of the empty object, but you can, of course, increase that to, let's say, 2, then it's double the size, but then you should increase this as well, that you can see. Now it's again both 2 units or 2 meters, and then you can see it again. Like this. Alright, but I will leave it at 1. For both. Alright, additionally to that, there is the texture fall off. It's a bit more complicated, but not that hard. Alright, let's put it back here. Alright, the texture, in order to use the texture fall off, you have to add a texture first to Blender. And Blender has some preset textures, you can access them here under texture properties. And then you just hit new, and then there are some presets. I will just use clouds, which is a noisy pattern of a grayscale, from black to white and a lot of gray values. And you can change the size here, and you can already see something happening here. Let me just increase the area a bit. So you can see that now this object here is representing the area of this texture. What this means is this gray values here represent the intensity of the modifier for every point itself. So every point now has a different value, as you can see. So this is now like a mountain. And when you increase the size of the pattern, as you can see, now this is way more noisy. And by this, you can see it's more randomized, the values here. But when I increase the size, it's very soft and not that noisy. And by this, it looks like, way softer. And now I can move this around, and you can see, when I move the second thing to second controller, you now have this noisy field as the strength, basically. And you can make this a bit smaller. let's say like this, it's alright. And now you have a mountain thing to move around, and that's pretty cool. Yeah, and for example, you can now add another modifier, let's say a subdivision surface to smooth it a bit, like this. And now you have a really smooth mountain. You can just emerge from that cube surface. And this is the warp modifier, yeah, it can warp geometry, and then of course you can modify that warped geometry with a subdivision surface modifier, for example. Yeah, and you can of course choose a own texture as well. So with image or movie, you can just import something from your computer. I just prepared something little Blender tutorial image with a little smiley, and when I view it from the top, you can already see it's there, kind of, yeah. I just want to increase the scale a bit, let's say on 2, like this. And then I just want to, let's move this back in the center again, like this. So now you can see that it's just a bit low resolution, because you see it's not that many points. So I just want to increase that a bit, that you can see an image on there. I just want to quadruple the amount. Now you can see that. So now you have a little image looking out from the surface. Yeah, you just need an image. The best case is just a black image with a white text on it, or an image on it, or a gray image, yeah, black and white with gray areas. With gray areas, it's a bit more smooth here. Yeah, if I just disable the subdivision surface, you can see when you have gray areas on your image, these areas are then more smooth. Yeah, because gray means it's just warped a bit and not that hard. Alright, and by this you can have little images on your surface. Alright, this was the warp modifier. You can see what it does. It's made for bumping geometry out of your surface. That's all for this video. Thank you and see you at the next one. Welcome to another video of the Blender modeling course, namely the modifier series. In this video I will show you the wave modifier. And to do that I built a little western town scene with the main road in the center, and I want to emerge there this bottle here, you can see it. I want to emerge it from the ground with a wave pattern here announcing that emerging bottle. And of course this bottle is way too small, so I want to scale it up for that. Like this, a giant bottle emerges from the ground with an earthquake-like, yeah, wavy patterns in the ground. And to do that, yeah, I need the wave modifier. Alright, so let's just select the sand here and add the wave modifier. It's the last one from the deform category. Alright, so after I added this modifier, nothing happened. That's because there is almost no geometry on this plane. I will go to the edit mode, and you can see I only have 4 points here, and I want to change that to a lot more. And I don't want to subdivide everything because I have a lot of unnecessary points then here and here and here and here. I just want to have the dense geometry here where I need it. So to do that, I just make loop cuts like this. Alright, and now I can just select this area and just subdivide that only like this. And then I have a lot of geometry here and nothing else on the other parts. By this, I can be very dense here without losing too much performance. Because you can already see, this is just a bit of the whole area here. And yeah, I don't need the actual geometry, but to be there. Alright, so let's continue. When I exit the edit mode, you could maybe see the wave happening, but you don't, so I just move it a bit. Here you can see the start of it. It's just so tiny because we're at the beginning of the timeline. You can see that it is, yeah, an animation basically. So it's just getting bigger and bigger. You could turn off the cyclic here, then it's only one ring, but I want many rings like this. And with these buttons here, you can disable or enable only single axis, but I want both axes. Alright. So, with this checkbox, you could do this on the normals. Oops. So, for example, if I would raise this area here, like this, the normals of this area would be here, pointing in these directions. Yes, as I mentioned before, the normals are the vectors looking away from the faces. And when I have this effect like that and I disable along normals, everything will move up and down, even here. Yeah, but if you want to move in this direction back and forth, then you have to enable along normals. Yeah, you can see the difference. Here it's just moving up and down, and with that, it's moving along the normals. So you can see the waves passing through here. Looks like this then. All right. It doesn't matter, so I just leave it off. And then here, the fall off is the important part now, because we have a border here and we want to hide that. So if I just keep it at 0, the border will be visible. But the fall off is basically the distance. Yeah, you can see that distance after which it fades out. So I can create here the distance when I want it to fade out. And I basically want it to be like this. With the start position, I can move the whole effect. Okay. And with the height, you can decide how big the waves should be. So I want them to be pretty big, like this. And with the width, you can decide, as you can hear, distance between the waves. Yeah. Here you have very, very narrow pauses between the waves. And with this, you have very big pauses. And I want to have it like that. Like this. And with the narrowness here at the bottom, you can read it distance between the top and the base of a wave. So you can see that at 0, it's basically no waves. And the higher you go, the more contrast you have, basically. So I want to have it about that. All right. Now I just want to go to time, because here you can see it starts at 0 and then it just goes on and on and on. But I want it to start a bit later, let's say at frame 20. So I set the offset to 20, so I have a pause here and then it starts. And then on live, I can decide how many frames this should last. So let's say 50. And then there is a pause from 0 to 20. And then it's going on until 70. Then the live of 50 is reached. And then it's gonna dissolve here. All right, so it's gonna look like that. And then it's going to dissolve. All right. So maybe we can overshoot the height a bit. That's just a bit bigger, like this. And maybe the fall off a bit smaller, or bigger, yeah, just a bit larger. Okay, like this, that's all right. And now we have our animation. It starts at 20 and fades at 70. All right, and now we want to animate our bottle. Yeah, we just can start at, let's say, we have to decide where we want to start it to appear. So I just move it down like this. And then let's say I want it to start to appear at 40. So just place it here. Keyframe the location with I. When you press I, you can keyframe certain things, or you just go here in the object properties and just hover over the location and then press I. Then you keyframe exactly this property here. And now we're just going to continue. On 70 it fades, so we're just going to right before that 68, and we're going to move that where we want it to be, about this. And then again we keyframe this at this frame. So we keyframe the location on 40 and we keyframe a different location at 68, and by this we created that motion. And we could add a rotation also, so let's just keyframe the rotation. So hover over the rotation and press I, and then again here, and then I just want to rotate it a bit, and then hover over the rotation again and press I again, and by this we made that little turn. We could even make this a bit more. All right, so now the base animation is done, but I don't like the motion of it, because you can see it's a bit weird. Yeah, that's because the standard or the default animation setting is a fading thing. Yeah, so the animation fades in and fades out. And I don't want to have that, so I just open a different window with the graph editor, where you can look at different animation graphs. That's not so important for the wave modifier, but for the animation, I have here you can see the Z location, which is the movement upwards. You can see that here. It's the blue line. And basically what this means is this animation starts slow. This animation starts slow, then accelerates in the center or in the middle of the animation, and then it decreases again its speed at the end. But I want it to be different, so I just grab this handle here and do it like that. And this means it accelerates pretty fast, and then it declines over time, the speed of the bottle. So now this motion is different, and you can see it here now. It's like this, for example. So it's fast at the start. Oh, I just noticed that. Alright, so you can see now the animation looks like this now. The waving starts, and then the bottle emerges, and then it's dissolving then. And by this, with the wave effect, you can create effects like this, or water waves, or whatever. Yeah, basically the wave modifier just brings the vertices or the geometry in waving motions, and by this you can create different effects. Or just on the x-axis, then you have straight waves moving in one direction, and so on and on. So the wave modifier is a bit limited because it's basically only this function, but yeah, the good side of it is that it's pretty fast to apply. You just need geometry and apply the modifier to it, and then you're finished. You have your waving motion. That's all for this video. Thank you and see you at the next one. Welcome to another video of the Blender modeling course. In this video I will talk about the snapping tool. This is a very important tool for the modeling process, and you can use it a lot. Alright, so where is the tool? It's here right at the top, the little magnet icon. When you hit that, let me just go to the top view. When you hit that, then you move on the grid. You snap to the grid lines here. And it's because of that, because here the snap to target is the increment, which is the grid. And the special thing about this is when you just move it, you are on the main lines. These are the thickest lines you can see here. But when you, for example, zoom in and you start to see these little squares better, then this is your new grab target, or your snap target, where you snap your object to. And when you even zoom further in, that you can see the very, very tiny squares, then these are your new snap targets. So, and when you zoom out and you start to see these very big squares, then this is your new target. So you have to zoom in and out a bit if you want to make your targets bigger or smaller depending on the zoom distance. Alright, so this is the grid snap. One special thing about that is if I am off the grid, so let me just disable that, move it a bit, and then enable that again. If I am off the grid, I can't turn back to the grid now because I just move in the distances of the grid. And when you want to go back on the grid, you can just enable the absolute grid snap here. When you do that and move it, then you jump automatically to the next point of the grid, and then you're on the grid again, and then you could disable it because then you are on the grid again. Alright, the next thing is the snapping to geometry. So for that, let me just add some geometry, the icosphere for example. So I just move it on next to it. And when I now, for example, want to move the center of this icosphere on a vertex, this one, for example, this corner, then I could do that with snap. And to do that, I have to just enable snap and then choose here the vertex target. So I want to snap to a vertex. And now here we have some options, and I want to snap not with the closest geometry. That would be, let me just show you, if I choose the closest, which is the default, it looks like this. Yeah, when I try to snap something, it looks like this. And you may ask now, that doesn't look like the closest geometry, because the closest would be that, and then it should be on here. but I can show you why that is so. For that, let me just enable the bounding box for the object, and you can see the closest target is always the bounding box, so you can't be closer than the bounding box. So when I try to snap it on here, for example, you can see the bounding box is the limit. You can't go inside of the object. Yeah, that's just because you don't accidentally clamp your geometry somehow and you overlap it. Yeah, for example, if I pull this out, you can see the bounding box expands as well. And to prevent that something happens like this, that you jump into the other object by snapping, it's just the bounding box limit, and it's then prevented just of the volume. So you can't go closer than the volume boundaries. Alright, so let's go back. So now, what I told you, when I want to go with a center on an edge, then I can just choose either center, median, or active. These three things, when you have only selected one object in the object mode, are the same thing, because center is the origin, median is the median location of multiple origins, but in this case we only have one, and active, yeah, this is the active object as well. So in this case all three would do the same. Let's just choose center and move it on there, and you can see it snaps on there. I can just scale it down and duplicate it, and then snap it on here and on there, and just duplicate it, and it automatically snaps on the corners. And by this I can very fast, yeah, put a little icosphere on the corners of this object. That's very handy, and that's why it's so cool to have the snapping enabled. And there are different targets for each of these. I can show you, for example, choose these four icospheres. If I want to make the median location, which is in the center on the corner, then I want to choose median here and then just place it on here. And you can see the snapping is then with the median position of these. And active, for example, if you chose multiple things and one of them is the active, then this is the snapping target. As you can see, it's always the top right one. Alright. And then you have other different things. Align rotation to target would be to, let me show you. For example, if we use the median again and apply that, then it's always gonna be the rotation. So on corners, it's a bit hard to see maybe because the average angle is in this direction. That's why they are oriented like that. But let's just choose a different example. A ball, and you can see it. So let me just use a cube and make it very small like this, or maybe even like that. And now if I place it here on a vertex, we can just leave on the center, but be careful, the center is now here in the middle, but I want it to be like this, that I can place it on the surface. And when I now hit the vertex snap on the center with the aligned rotation target, I snap 2 points with their rotation. So this point here looks in that direction, and this point here looks in that direction. And by this you can put objects on surfaces like this by hand. But the better way to do it is with the face project. So you can place it, as you can see, on different geometry things, for example an edge, and then you have the edge here, but this edge has not really a direction, which is useful. But for example, the face project is just place something on a face or snap to face. And when we have the aligned rotation to target enabled, then you can see it will automatically rotate like the face. And by this you can place very fast things on a surface like this. And then you have your ball with these cubical things on it in a couple of seconds, because of the snapping to a face. And there are just some limits you can enable. For example, let me just enable the face orientation. Blue means outside, so the correct side, and red means inside. So if I just flip the normals of this, then it's pointing to the inside. So this means we see the wrong side of this object. And now when I enable backface culling, which means exclude back-facing geometry from snapping, and you can see it will snap to the inside. Because I told Blender only to snap on the blue side. So you can see only blue, but the blue side is looking on the inside. Then I can maybe delete a couple of points that you can see it. So the blue side is the inside and it doesn't snap to red sides then. Alright, let's go back. So these are the most important things for the snapping to know, to model things. And there is another big nice thing to know. For example, it's similar to the snapping, but it's a bit more, it's without the tool enabled actually. So you can snap to edges with the G button. So when you press G, as you know, you can just move things. And with G, you grab a geometry to your cursor. And then when you hit G again, then you can snap your point to an adjacent edge. And by this, you can really nicely correct certain areas of your geometry. For example, if you want to create more room here for a Boolean cut or whatever, then you could move these points out of the way just by pressing double G, and you don't destroy any geometry here, because a face like this always has to be on one plane, on one level. So it's forbidden for a face to be on three-dimensional axis. For example, a face like this is okay, but a face like this is not okay. And you can already see, you maybe see some errors happening. In this case it's alright, but you can see this is not a correct face, because this is not a three-dimensional face, and that's forbidden, let's say, in 3D. And to repair this, to make a complete thing out of it, you could just connect these edges with the hotkey J. You can connect them, and now you have two planes again, which are two-dimensional, and then it's fixed. But this, for example, is forbidden, and by that you could repair something. For example, if you just enable the auto merge and move it on here, and then it's two-dimensional again, and so on. So with this double G moving, you can move points along an edge, which is very useful for the modeling process. That's all for this video. Thank you and see you at the next one. Welcome to another video of the Blender modeling course. In this video I will talk about the snapping again, because last time I talked a lot about the snapping in object mode, and today I will talk about the snapping in the edit mode. Alright, then let's get started. At first I want to go to the snapping menu here, and then I want to show you the next snapping target, which is the face nearest. It's just the nearest point on a face. It's a bit different than the face project. You can see that here when I enable the snapping and then have another object, for example, a plane. You can already see that. Alright. So when I now activate the snapping to the nearest point on a surface and I just hit G to move, it already snaps there. So with this enabled, you cannot target anything except faces. You can see that I can only snap to surfaces now. I can't even move away from it. So by this, you always make sure you are on a surface. Alright, that's just for that one. Okay, so now we come to the edit mode thing. The next one is the volume, and the volume target is basically, that you can only go into objects. When you have the snapping volume and you have your orange circle here for the snapping indicator, then you are inside of an object. So the volume basically means I am now inside of an object, and by this you can tell if you're inside or not. but that's just for the completion of the targets. Alright, so the next one is the edge center, and now we are really in the edit mode. The edge center is basically half of the distance of an edge. For example, on this edge it would be exactly this point. And when you have this enabled, you can see that you snap on the half distance of the edge here. So when I, for example, maybe you can see it better if I enable the wireframe, and then you can see the edges as black lines. And when I now create some subdivisions here, then you can snap only on the half points here of the edges. You cannot snap to points and the corners itself, but only to the half points here. Alright. And the last one is the edge perpendicular, and with this you can search the shortest way to an edge. So let's say, let me delete this. Alright, so let's say I want to create the shortest path from this point here to that edge. And the shortest path would be a 90-degree angle here, from this line to this edge. And to find that, for example, if this is a bit rotated like this, maybe it's hard to extrude this point here to that edge in the shortest way possible. So in the 90-degree angle here. And by this, you can use the snapping. And when you do that, it will snap to this point like this. So you have to kind of find it. Yeah, so it doesn't automatically apply when you hover over the edge. But if you come close to the point, you can see it snaps here to this point. And when you did that, you can be sure that you have a 90-degree angle here. Alright, and the same thing here, for example, when I make this a bit, crooked like this. And again, I just copy that point and I want to find the shortest path to it. Then you can just, for example, extrude this point and roughly move where you expect the point to be here, and then you have again here your 90-degree angle. And by this you can find the shortest paths to an edge, with this snapping target thing. Alright. So now I will show you some examples for snapping in the modeling process. So let's say I just add this icosphere. And now I just want to add a floor which is right at this point here. That's perfectly balancing on the last vertex here. For example, what you could do, you could create a plane or something, but we're in the modeling process now, so I can just create a floor. Let's say I want to have a kind of round floor. I could just steal some geometry from this icosphere already, which is already there. So I could just copy this one, for example, and move it down on the z-axis. And then I could scale it. Oh, let me just disable the snapping. Then I can just scale it down, but only on the z-axis. And I want to scale it down to 0, because if I do that, every z value of these points would be the same, because I scaled the difference between them to 0. So I can just type in 0 and press enter, and so I have a floor now. And then I could place this here and just scale the floor up like this. And if I want to make it perfectly to the point, then I could use the snapping vertex and move it there. And you could additionally press Z to be sure that you only move the floor upwards, like this. Alright, so now you got the floor exactly on your geometry of this object. And now, for example, another snapping example. When you want, let me just move this down. If you want to create a plateau here, that this sphere doesn't stand on one point, but on a little surface here, a little plane, then you can move this up until here, and then it's like this. They have a little surface to stand on. And to do this nicely, you can just snap this point on the exact same height as the rest here. And you can do that by just pressing G to move it, to grab it, and then move on some of the points of this height. And by this, you move the points to the same location, but you don't want to do that. For example, on this one, by that, you would be creating double points here. And that's why you only want to use the height for it. So for that, you just press G for grab, and then Z to limit the movement only on the Z-axis. And then you move your cursor to one of the points on this height. So it doesn't matter which point of these, it's all the same height. So you just hover over some and just click. And then you can see, let me just move this upwards. By the way, if you hover over some geometry and just press L, you select all linked. You can see that here. So linked means every point and every connected point to that. So these are not selected because they aren't linked by geometry. If I would link them like this, and then I hit L on this one, so everything will get selected. But since they're not connected, you can select certain chunks of geometry which are connected with L, just for your information. Alright, so now I can move this one down again with the snapping, like that. And now it stands perfectly on the surface, on a little plateau, and looks way more stable by that. Yeah, and for example, this is just an example how you can use snapping in the modeling process and so on. Yeah, for example, let me just give you another example. I can just select the rim here with Alt clicking an edge, then you can select a loop, and then if I want to make walls here, oops, which are exactly the same height as the sphere or half of the sphere, I could just like before press E to extrude, then hover over some points which I want to copy the height of, and then I just press Z to limit it on the Z axis again, and then I can click. And by this I created a little wall here which has exactly the same height as this point. And so you can just steal the information from different things of geometry, for example these points, and you could extrude it again and scale it up, and then you could create a second step here with, let's say, this height, and then again, and then you could scale it up on this height. And by this you created now some stairway or something which is just like the geometry or from the height points the same as the sphere. You can look at it from the side and you can see it pretty well. So the first step here is exactly on this height, the second step is exactly on this height, and the third step is exactly the same height as the whole ball now. Yeah, and by that you can control your geometry in a very good and efficient and dynamic way, that you can know where your points are when you just use the same heights for certain things, or maybe you just want to move them to another point where you have some geometry already. That's all for this video. Thank you and see you at the next one. Welcome to another video of the Blender modeling course. In this video I will talk about the 3 general concepts of modeling. Because in modeling there are basically 3 different attempts to approach a modeling project or object. Alright, so let's start with the first one, which is the hard surface modeling. As the name already suggests, in this concept you work with hard surfaces. So when I, for example, want to display something out of metal or a machine, then I just work with this actual geometry here to build that machine like this. Yeah, just for example, a machine or whatever with exactly this geometry, what the points suggest or show. So I don't work with any smoothing modifiers or whatever. I could bevel things, this is hard surface as well, like this, beveling edges, but this is still the actual geometry of the mesh which you're working with. Alright, so now you know hard surface modeling is just working with the actual geometry and moving points around and so on. Like this. This is hard surface modeling, for example. Alright, now we'll come to the second object. I will move this a bit to the side. Alright, now I will just add another cube. Now we come to the second one, which is the subdivision surface modeling. And as this name suggests, you are working with the subdivision surface modifier for this. So let's add it here. Let's go a bit higher on 3 or 4. And with this modifier, you smooth the geometry and increase the geometry count as well. But now everything is pretty smooth and you can create things like figures or plants or just soft material things like candles and stuff like this. Yeah, so on the subdivision surface modeling approach, you can see you're working with very soft things here and very soft models like this, yeah. And because of the subdivision surface modifier, you can control the geometry with this original geometry, yeah, because if I disable the modifier, you can see what I actually built. But of course, I'm not really looking at the original geometry, but to the geometry with the modifier active. And I just use this original geo as a controller to model the, yeah, let's say the wanted geometry of the subdivision surface. Like this, yeah, and by that you can see you can model very smooth things very easily, and that's, yeah, its own modeling category because it's a bit different from the hard surface modeling, as you can see. So this is the second concept of modeling, which is the subdivision surface modeling. Alright, and you can use this, as you can see, yeah, for the soft objects you want to do, yeah, because it would be really hard to model this with hard surface operations, yeah, like just moving these hundreds of points around to shape a form like this, yeah, and because of that you just use the modifier and start modeling with the modifier active. Alright, so now the third concept is the sculpting. Alright, so I will just add another object here, and then I go to the sculpt mode in Blender. And in sculpting, you really paint the geometry on an object, yeah. The problem here is I almost have no geometry. I can enable here the wireframe that you can see. I can't really, you can see it a bit, but the geometry doesn't move at all because it's just not enough. So if I enable dynamic topology, okay, then Blender will create geometry where it's needed. So for example, you can see when I start to draw, Blender starts to add geometry here, and when I zoom in, it will add more dense geometry. And by this, it's very nice to model because it really depends on the distance to the object, and you can, yeah, paint some geometry on here. And as you can see, this is pretty dynamic and, yeah, even more dynamic than the subdivision surface approach. Let me just disable now the wireframe. Alright, and you can see now I can just start to model on this cube here, and I just draw or paint the geometry on the object. And this is the third principle, the sculpting process. And for that you have to be in the sculpting mode to be able to draw this geometry here. And you can use this, as you can see, for very organic things, yeah, for example, yeah, plants as well, and of course character design and everything like this, yeah, animals and all kinds of flora and fauna. Yeah, and here you can see what you can do with it. Yeah, you can smooth everything and extract and subtract the geometry from here, and by this you can just create very organic things. So I just modeled this kind of thing pretty quickly. I don't know what this is, some kind of tentacle sitting on a cube. But yeah, just to show you how this principle looks. Alright, and yeah, now we can just put them next to each other so you can see them pretty good. So here you have your three principles. The hard surface modeling for machines and really hard surfaces like metal or wood or hard plastic and stuff like this. So that's for the hard materials or the hard appearances. This one is for the more soft appearances like candles and stuff like this. Yeah, just soft materials which look easy to dent or to reshape it, or that you could just grab it and reshape it like a piece of dough or something. Yeah, so this is for these kind of objects pretty good. And yeah, the third one, the sculpting, is of course very nice for these, but especially good for more illustrational approach to modeling by drawing geometry on things and very organic shapes. And of course you can combine them a bit. Yeah, for example, on this machine, as I showed you before here, so let's say I want to have a very hard machine like this, and then I want to have an organic thing on it. Then I can just go to the sculpt mode and let's see how the geometry looks like. Not enough geometry, but let's go to the dynamic topology again. Yeah, it creates triangles here, as you can see. And then of course you can draw something here on the edge, like this. Yeah. And then of course you can combine them in some way. Just draw some organic thing here, like a growing mushroom part or whatever, yeah, like this. And then you can see when I disable that again. Yeah, so you can have, of course, organic shapes on a hard surface object. Yeah, sure, you don't have to be afraid to combine them. So you can see it here. You can, of course, combine them. Yeah, you just have to be aware that you alternate the geometry pretty hard if you work with things like dynamic topology, like I did now. Yeah, so, but if you're aware of that, of course, you can combine different approaches on the geometry part of your object creation. Yeah, so this was now an example for combining different concepts, but in general there are three. Yeah, hard surface, subdivision surface, and sculpting. And on this one you have to apply it in the end, yeah, because as you can see the original geometry is like this. In the end you would have to apply it if you want to process it further. And then you have this nicely distributed geometry here on this object. Alright, so this were the three different concepts of 3D modeling in general. That's all for this video. Thank you and see you at the next one. Welcome to another video of the Blender modeling course. In this video I will talk about joining objects and the proportional editing tool. Alright, at first let's start with the joining part of this video. As you already know, are objects just containers for data. So for example, if I add another object, this here is just container 1, let's say this one. And this one is container 2. Alright, and in these containers are different geometry data. Alright, and when you now join two objects, so let's say I want to join this object to this object, then I have to select this and select this with this one as the active object, which you can see on the yellow outline here. Now you can just do a right click, for example, and click join, or as you can see, Ctrl J. When you do this, you can see I only have now one object here, container 1, and it contains this data now, and this data, which is called cube, contains this cube and this sphere. When I change it back to sphere, it's this one, and when I go back to cube, now this are multiple geometrical objects. Alright, but nothing really changed on the geometry level here. So I just added now this geometry to this object, but it doesn't really change anything, except when you have modifiers enabled on one of the objects. Let me just go back. For example, if you have here, let's say an array. Let's make this in that direction. So I have an array where it's just copied along a line, and I add this object to that object, then of course the modifiers of this object will be applied to this as well, to the sphere, because I just joined the sphere geometry to the object here. Alright, so this is important because it's often not necessary to join objects, because on the geometry level nothing really changes. But there are some situations where you want to really join different containers together. And one example is when you want to merge them together with, for example, a remesh. So let's say I want to have a cube with this half sphere on top of the cube, and then you could just join them together to this shape. But remember, this is still just the assignment to different objects, which is now one, but it's still separated. Yeah, you can, if you hover over a geometry and press L, you can select all linked points. Yeah, and by this you can select them, and you can see they're not joined according to the geometry anyway. But now when they are in one object together, you can remesh them, and then you can see with the remesh you can really join them together like this. Alright, when I apply it, you can see now they really merged into one object, and there is not just a sphere stuck into a cube, but they are really joined here. Yeah, that's because with a remesh you work with the volume of the object, and the volume, here you can see that the volume is exactly this shape here when you have them as one object. So the volume of the object is really affected by multiple geometry things inside of that object. Yeah, or in the edit mode, when you open the add menu, you can add geometry to the object. So you don't add a new object, but geometry to that object. And for example, when I just stuck the monkey here slightly into this cube and have my remesh modifier here, you can see this is also, yeah, kind of melted into the shape of the cube, yeah, by the remesh modifier. And by this, there is, yeah, or there are some occasions where it's really helpful to join objects. One example is here, as you can see, when you want to remesh different geometries into each other by, yeah, kind of melting them together. But aside from that, usually it's not necessary to join objects, because you can also, if you want to edit multiple objects, let's say I want to edit them together here, then for example, I'm in the edit mode here, but if you can see, if you select multiple objects, you can edit them, yeah, parallelly. So it's not necessary to join them into one object like this to edit them together, yeah, because it's possible without joining them too. Yeah, you can just select them both and then go to the edit mode, and then you can do this, and they are separated objects, but yeah, they were edited just at the same time. Alright. Okay, so far for the joining part. So as you can see, it's sometimes necessary or helpful, but yeah, not that often as you may think. It's just, yeah, you have to ask yourself why you want to join objects and what advantages can you get from it. Yeah, because often you just work on a geometry level, and in these situations it's not really necessary, because yeah, as you can see, or as you saw, geometry doesn't change. Alright, so now we will come to the proportional editing part, and here we can join objects too in the explanation, because here, this is the proportional editing tool. If you enable this and move a point around, I enabled it in the object mode, but I want to have it in the edit mode here. So if you move a point around, you can see with my mouse wheel, I have now an influence area around my selected point. And in this influence area, you can see the points do kind of the same motion. Yeah, I can rotate here, or yeah, scale, like this, and of course move this point. And you can select multiple points, and then you have influence areas around these points. Yeah, you can see that here. This is very, very helpful for many things, yeah, because maybe you want to shape your sphere a bit and don't want to do it every vertex by its own. And by this you can shape some things very easily in here, yeah, like this. Or if you want to make a dent inside like that, that's very easy to do with this modifier. So with the proportional editing, and there are of course, yes, several modes. Let's just use a plane with some subdivisions here, like this. And here are some shapes. Yeah, you may know these shapes from different modifiers because they are the same. For example, the smooth is just the normal distribution. But for example, if you use this sharp graph and you pull something up, yeah, you have this, yeah, very sharp shape of it, yeah. And in contrast, let's say a sphere, when I lift here something up, you can see it's like a dome here. Yeah, and so you can have different shapes how you want to, yeah, have your proportional editing. And why did I say now we can use the join object thing here too? That's because the join object can be used in different ways. So let's have two spheres here, like this, and now I join them together. So now I have an object with two sphere geometries here. Yeah, this is the one and the other one is this one. And when I now enable the proportional editing and I move this one, or let's say I want to move this area here, you can see every point in this influence area moves, even the points which aren't connected, yeah? So the spheres here aren't connected, but they still move when I use this proportional editing. Alright. And you can change this here when you select connected only. When you check this checkbox, yeah, only the connected vertices have an influence or are being influenced then. The other points aren't, yeah? So you can move them with this proportional editing individually, yeah, and isolated from the other object. Yeah, so that's often very useful when you have, like here, objects which aren't connected next to each other and you only want to reshape one of them. Then you can use this, yeah, like that. And when you want to start shaping them both or influencing them both, then you just uncheck this, and then you can see you can again, yeah, make them both being both influenced by this, yeah, and by that you can then, I don't know, yeah, roll them together like this with the proportional editing tool, and then you have them both selected again, and then you can switch back, connected only, and then again maybe you want to reshape only this one, and so on. Yeah, by that you can just play around with it, with the influence area, because it looks very smoothly, yeah, because the influence is a gradient which declines over distance, and by that you have very smooth control over the geometry. But don't forget to switch it off, yeah, because if you accidentally leave it on and want to move something later, maybe you destroy a bit your model without noticing it, yeah, so it's good to just disable it if you don't need it anymore. That's all for this video. Thank you and see you at the next one. Welcome to another video of the Blender modeling course. In this video I will talk about normal vectors in the modeling process. Alright, so normals are very important for many things in 3D. At first, they are very important for the shading process, which I will not talk about in this video, but that you heard of it once. It's very important for the shading, because the angle of a face is very important for the amount of reflected light and the color in general, because of the light influence and all of these things, yeah, or on a mirror or metal, how the image is reflected and all of this. So it's very important for the material, but also for the modeling. And this I will cover in this video. Alright, at first I want to change the view to perspective with numpad 5, or with this grid icon here. By this we have a perspective and it looks a bit better for you to look at maybe. Alright, so let's change this cube to a sphere where we can see a bit more, and you can see more faces on it which point in different directions. Alright, so a normal vector or a normal is a vector which looks straight away from a face. Yeah, if you take this face here, this vector looks away in a 90-degree angle from this face, and this is the normal vector. Yeah, it has usually a unit of 1, so you can just imagine it like this. You have this face has that vector and so on, and they look away like little needles. Yeah, like this. And you can display the normals in the overlay. Here's the overlay menu, and you can enable them, but for that you have to go to the edit mode. So let's go to the edit mode, and then the overlay menu is way bigger in the edit mode, and all the way down here you can see the normals. And here you have the face normals, and you can see them, and you can change the size, of course, also, but let's just keep them not that large, just for overview. And here you can see the normals. Every little needle here points away from the face, and when I change now the geometry here, you can see how the needles move, or the normal vectors, because, for example, this normal vector looks in that direction, but if I now move the lower points of this face, of course the angle of the face changes, because the angle is defined by the attached points, and if I move the points around, the angle of this face of course changes, and now it's looking straight up, or almost straight up. Maybe I could move it a bit more like this, and now it's pointing almost straight up, and by that you can change the direction of a face. Alright, let's just go back here, and now I want to show you why these normal vectors are so important for the modeling process as well. At first, it's very important to know in which direction your geometry is looking. So for example, if I delete this one point that you can see inside, here you can see no needles because they are only on the outside of an object, or the correct side. And you can display that here with the face orientation. Blue means the correct side of a face, and red means the wrong side of a face. And the correct side should always be the outside of an object, because that's how these objects work. With these objects, I mean, for example, a mesh object like this. So the correct side should always be on the outside. There are some software on the market which don't even display the wrong side. So if you would look on the inside now, you wouldn't see any geometry here because it's just not displayed. But in Blender, for just convenience, you can see every side of the face. And you can display the correct and wrong side with this face orientation. Alright, so now we'll really come to the modeling part. Okay, so if I just add a modifier, for example, let's say a solidify modifier, this modifier decides where to thicken things dependent on the normal side. So on the normal vector, on which side the normal vector is, because this is the outside. And when I now increase the thickness here, you can see the inside of the object becomes smaller because the walls are getting thicker. And with this offset on -1, I tell this modifier I want to increase the wall thickness by decreasing the inner part. And how does the object, or how does Blender or the modifier know what is the inside and outside? With the normals. So let's just look in that here. So here you can see slightly the inside sphere and the wall. Wait a second, let's just go here in the orthographic view. And when I now decrease this angle, or this thickness, you can see the wall is shrinking. Oops. Alright. And now if I change, for example, the orientation, let's say for these faces, I want to change their orientation that this is now the outside, I can just open the normals menu with Alt-N, for example. And then just here, the first one, flip. And now, when I disable the modifier, it becomes red because it's the outside now, the wrong side. And if I delete here one chunk, you can see now this is the outside here. So I just flip the orientation. And now, as you saw it before, the modifier now thinks this is the inside of the object. And I told him with this offset on -1, I want to decrease the inside space for the wall thickness. And because now this is the inside basically, because it's the wrong side of a face, the non-normal vector side, you can see Blender kind of tries to decrease this space here by moving that face inside there. But of course it's not working because I made a mistake basically by changing these areas here. So it's important to have the faces correctly on your object. Again, Alt-N, flip, and then I repaired it. And sometimes it can happen by any modifiers, something that you have wrong oriented faces and you have to spot these mistakes. The best way is here to just enable the face orientation and look at your model. Alright, now this would be okay, and I know this is not the error if I would have one. Then furthermore, let's delete this modifier. Many operations use the normal vector as a direction, and the most prominent example would be the extruding tool, which we used a lot in the modeling part. And for example, if I press E to extrude the side, you can, you may already know, it will extrude it along the normal vector, like this. It will always extrude along the normal vector. If I rotate it now, my normal vector shows in this direction, and when I extrude it, it will be extruded in this direction. So the extrusion, for example, is extrude along normal. And you can, of course, move a face along a normal as well. The shortcut would be Alt-S. That's move along normal. In Blender, it's called shrink or flatten. And the icon is here. Shrink, flatten. That's the same thing basically. But the shortcut would be Alt-S. And this is, you can name it move along normal. And you can see that, for example, this one here, when I move this face along the normal, this face here changes its angle, of course, because it's connected to that face, and by that you can change the normal direction. And for example, if I just put it back where it was, this direction now would move in this if I extruded it, for example. But if I now move this and change this angle, it would extrude in this direction, and then you have to know this, that you change the normal orientation or the normal direction of adjacent faces when you edit something. For example, if I now move this in that direction, every faces connected change their orientation as well. For that. And then I just kind of build a pretty bulky dent here, and then here the outside faces looking in very different direction now. It's almost like a sphere for itself here. And then you can extrude these parts in exactly these directions. That's just an example for moving objects or moving geometry along normals. So you can model with this, and it's very important to be aware of that and very important to know about the normals, not only in the shading but in the modeling as well. As you saw here, the control of the normals is very important to master modeling and shading, because it's such a big role to know where your faces are pointing at and why, and how to repair them and so on. A way to repair them, for example, could be to steal the normals from another object, or just manually move them where you want them to be, and stuff like this, for example. So it's very important for the modeling process. And if you're finished now with the looking at your normals, you can just disable everything, of course. So disable the normal display and the face orientation, and then you have your object like before, but after the repair of the normals or the control of the normals, then you can proceed with the modeling with a clean model. That's all for this video. Thank you, and see you at the next one. Welcome to another video of the Blender modeling course. In this video I will talk about the text function in Blender. And this is a very cool topic because Blender has a nice text editing tool inside of its 3D environment. Alright, so at first let's delete this cube, and then we will add another object, because in Blender the text is its own object type. So we just add an object with the add menu with Shift A, and then you can already see add, and if I just hit that, a text object appeared here. Alright, so it's a normal object, yeah, with a center here and everything else, but it's a text object. And this means you can see here under the object data properties, you can edit pretty much here. Alright, so at first, the most important thing, how to change this text. You can change this text just by entering the edit mode, because the edit mode in this object is changing the text, nothing else. So I just hit tab to enter it, or just go in here, edit mode, and then you have your text. And then I can type anything else. I am a 3D text. Alright, and then hit tab again, and then you changed the displayed text here, which is pretty fast and nice to do. So this is very cool. Alright, so then when we're in this menu here, you can see, for example, the first thing you see is the resolution. If I reduce it, I just reduce the amount of points of this. So I just reduce the geometry. And you want to have this pretty high, yeah, because then everything is nice and round. The default is 12. That's okay, I think. Alright, then you have a fill mode, which has to do with the 3D writing, but I will come to that after this one. So you have your geometry settings here of your text. And for example, you can have an extrusion of the text to a real 3D typo. Alright, so if I just slide this up, you can see I extrude the faces of the text or the surface. For example, let's do it like this. And now you have a 3D text, and this text is now correct because it is now a 3D text. And now we just jump back one field to the fill mode. Currently it's on both. Basically the fill mode says how the surfaces here should be filled. So this is the front, yeah, and this here is the back. And for example, currently they are both, but if I change it to none, it's only the walls of the 3D text now. And for example, only the back would be this, then it's like a cup or something where you can fill in water or whatever. Or only the front, then it's like this and it's open on the back side. Or as it was before, and it's on default, of course, as well on both, then it's just closed and you have your waterproof mesh 3D writing now. Then we have an offset slider here to change the shape of the text a bit, but this is, I would say, not that nice to use because it's causing a bit trouble and often you destroy the geometry of your object. I would not recommend to use that often, except you have to use it for some reason, but it's a bit weird and it moves the walls a bit around. Alright, then another important thing is, for example, the bevel. With the bevel, you can bevel the edges here, like this. But you have to take care, this destroys the geometry a bit too, because it creates some overlaps sometimes. For example, here, because it increases the radius, it increases the radius, you can see that, so the letter is getting bigger. And you could, counter that by decreasing the offset a bit, but as you can see, for example, here, it's not optimal, so you have to be very sensitive with the offset slider, that you don't destroy any geometry. But that's how you could do it, you could add some offset to your text and make it more slopey here on the rim of the text. That you create slopes here, like on a bevel. Alright, then we continue, because another very important thing is the font. You can, of course, change the font of the text. So let's zoom out a bit. Currently it's like this, it's the Blender default. But for example, let's change it to something different, like this. Let me just decrease the depth. Alright, and then it's like this. And now you have your 3D letters in a different font, and you can install any font and just add it to your computer's font library, and then Blender can have access to that. So Yeah, you just have to select it on your computer. Then you have your transform settings here too, so size and or shear like this and so on. And of course other text editing tools as well. It's here under the paragraph category. So for example, how it's oriented. Yeah, is it left or center? And you have to look at it like this. So this is the center line because the origin is here. Left, center, or right. Or something like this, justify or flush, and so on. So these are the, I would say, default text editing tools. You can use that as well, or where it's oriented in its line, top or center. Yeah, again, the origin is here, so it's oriented in the center, and however you want it to edit, yeah, your text in general, the position of it. So let's leave it, let's say, on top or on bottom. All right, and then you have, of course, the spacing here, character spacing between every letter, or let's say I am the second line. And then you can change the word spacing and the letter spacing, and then the line spacing, of course, too. How far should the lines be apart? And then just a offset, a general offset of the whole text and Y and X axis to position it a bit. All right, this was how you can use the text in general. Yeah, just play around with it a bit and then you can create 3D text. But now I come to another important topic when it's about the text, which is how to convert this into a 3D object, because currently when I press tabulator for the edit mode, I'm in the text editing thing here. So I can't really access this 3D data, which you may want to do if you want to animate it or something. And for this, you have to do a right click, for example, and then convert to mesh. If I do this, I converted this into a mesh and everything seems alright. But if I go now to the edit mode, you can maybe see that the objects are not perfect. Yeah, so the topology is not that nice. At first, it's only triangles here, a triangulated surface or topology, and it's very contrasty. So here you have very low poly count, and here, of course, in the curves you have a very high poly count and so on. So it's not that nice to use for certain things. So for example, if I want to bevel it, let's go on here and let's select this. So if I, for example, want to bevel this top thing, you can maybe see it's not optimal. So it's kind of broken and even open here. So it's not really closed. And for example, you would have to select everything and then you would have to merge them. So let's just do that. Mesh, merge, and then merge by distance. Then I removed almost 7,000 vertices, which were doubles. And now everything is connected, but even now, if I select something here and try to bevel it, it works for the first couple of things, a couple of millimeters, and then it's getting broken. So the geometry of the letters is always pretty broken, and you would almost every time fix it. The easiest way would be to just remesh them, because the remesh is only looking on the volume, and the volume is correct. Yeah, the volume is okay, but the topology is not okay. So the easiest way would be to just go to modifiers and then remesh these. Alright, now it's pretty soft, as you can see, and I just have to reduce now the voxel size to something which would be okay for me. So let's go to 0.005. So this could be okay. It's sometimes it's a bit close here, so let's go even smaller like this. Okay, so this is a bit too close, but for example, let's take this one, for example. If I now apply it and go to the edit mode, you can see that it's pretty dense now, but the topology is fine now again. So now you could work with it and yeah, let's say you can select some parts here and then just pull them out or something. So it's alright. So you can edit it, of course. It's now computer intensive or computing intensive to edit these. But yeah, maybe you can choose a lower resolution. But that's the quickest and easiest approach, to just use a text tool and, for example, remesh it to be able to really edit something, because the geometry of the default converted text is pretty broken. But if you can use it, of course, but most of the time it's not really usable for animating, for example, because it's just too broken. And then you have to fix it a bit, like this, for example. That's all for this video. Thank you and see you at the next one. Welcome to another video of the Blender modeling course. In this video I will talk about the topology. So what is the topology? The topology is basically the property of the surface of an object. For example, this cube here has a pretty basic topology because it has only 8 points which form this or these 6 faces. But let's just make a subdivision and then you can see the flow of the geometry of this object. In this case, it's just, loops around the object here. You can see that here. When I click them, this cube basically consists only of loops around the object. By the way, this is the best way to display an object with looped edges. So this would be a perfect mesh. That's because you can select these loops and can modify it pretty easily, and this also means that you only have quad faces, so faces with 4 points here on your mesh, and this is very good for modeling and processing and editing and so on. So this would be a very good mesh. But unfortunately, not every mesh is as simple as this. So let's, for example, make an example for a bad topology. And for that, we will add a text, because texts have really bad topology when you convert them into a mesh. So at first, let's extrude this a bit like this, and then convert it to mesh. And now it looks like this. So let's look at it from above to see it a bit better. Now you can see the topology of the object. In this case, it's not that good because, maybe you can see it, on the curved areas here, you have very high density of points. Here, this one. So you have very dense geometry here. The points are very close to each other. And on faces or areas like here, you have very long edges and very long spaces between the points. And here you have, only long spaces here, for example. And that's a sign for a problematic zone. It doesn't have to be problematic, but it's an indicator that maybe some things will produce some errors in the future. And one thing is, when you convert text into a mesh, you have often open meshes. So they are not waterproof, they are sliced up basically. So let me show you how I know this. So for example here, when you have a surface like this, and you just subdivide it a bit, that you have your points here, you can see that on the points, or on the edges of the points, an orange color is fading to black to adjacent points. By this you can tell if a point is connected or not. So if you, for example, select multiple points here, or vertices, you can see that the edges between them are orange. Yeah, that's a way to tell if they are connected or not. So these are connected and selected. So this edge is basically selected. And when you have a connection to a not selected point, but still connected, it's fading from orange to black. And by this you can always tell if something's connected or not. Alright, so let's delete this and go back to our text here. And by this you can, for example, already tell, if I zoom in here a bit, you have these fading orange colors from orange to black here in this direction. So on this edge, and on this edge. But on this edge you don't have these this orange fading color to black. And because of that, I can already tell that this edge here is problematic. Namely, it is not connected to this point. And when I move now this point, you can see that, yeah, it's exactly as I said. So when you click on a point and it don't have one connection here, you can tell that it's a problematic point where you have to do some fixing. So you can now check some of these. So this is not connected as well. So basically it's like this. So this T shape here is isolated from the rest. And yeah, a very easy way to fix this broken topology. So now this topology here is, for example, broken. It's, yeah, not usable because it's open and then many errors will occur. And to fix that, there's luckily a very good fix for this, which is the merge option. When you just merge points together when they are very close, you can just make this point and this point to a single point, which is just merged then here. And to do that, let me just delete this annotation. So to do that, you can just select every point here with A in this object and then go to Mesh, Merge, and then Merge by Distance. Then you can already see 354 vertices were deleted, but you can open here this menu, for example, and just choose the distance when the points are merged or should be merged. And you can, for example, increase this, and then you can see that more and more points are merging together. So if you have a too high distance here, your object will just collapse into one little line because the objects or points are then very close there. So you have to adjust it a bit. Alright, so far for the merging process, and then when you are done, you can see you have now these fading colors here, or the orange color in every direction, which means this is now alright. I mean, it's not really alright, because it's, as you can see, not connected to this edge, and you would have to fix that as well. So, but here you can see how a broken topology looks. So the property of the surface is very broken. So you can't really use it without producing errors. So for example, if you want to fix this here, so it's on both sides basically. So what you are having here is a not connected edge here. So now how to fix this broken edge? Yeah, as you can see, when I move this, you can see that you have multiple edges here. For example, from this end here as well, you have this one very long edge. And if you now select it, for example, that one, this is not necessary basically, because you have a connection from here to this point, and then to this, and then to this. So it has no use to have an edge from all the way here to here as well, but it was created by converting it to a mesh. And to fix this, you can just, for example, select it and delete this edge. Then it will look like this, and then you could just close it back together with, this would be not that optimal, but it's okay. So I now create an n-gon, which is a face with more than 4 points. But now it would be closed, and this would be connected here as well. And this would be broken as well, so I have to find the second wrong edge here, which is this one. You can see it pretty well here that you have multiple wrong edges, so I want to delete this one as well, and then again connect these. And now you're fine. So now you can see you have a connection here with every connected point, and here as well, and now it would be repaired. So you maybe have to sometimes delete certain parts of the geometry and just rebuild it by hand, for example, or with a tool to just repair the topology. So the topology is something to look after while editing things. That's important because a broken geometry or topology, which is basically a flow of geometry. I can give you another example. If I have now a UV sphere here, just the normal UV sphere, and I add a cube and subdivide it a couple of times like this, for example, and if I now use the cast modifier, which is here, to make it to a sphere like this, and I apply it, I mean, okay, the size is a bit smaller, but they basically have the same shape, but they have a different topology. For example, if I now subdivide this one, you can see Oh, let's just use a modifier like this. Now you can see that these objects here, let me just maybe enable the wireframe. You can now see the different topology of these two spheres, although they both are spheres and have basically the same volume or the same shape, but the topology is different here. So this one here has a geometry flow like the Earth from one pole to another, and this over and over again like this. Yeah, this is basically, yeah, two poles, one bottom and one on the top. And this one here was, yeah, a former cube, and you can see it a bit because you can see the corners here. Yeah, maybe if I zoom out a bit, you can see that this was a face before. And the corners are here because the geometry is more dense here. But here, for example, you can see how the topology can affect the geometry of objects, although they have basically the same shape. And this can be problematic with some models, for example. I just can give an example here. It is very nice and easy to just extrude this one pole upwards. For example, if I want to extrude it, I can just do it like this and have some kind of cylinder now looking out of the sphere. You can tell here that it's not that easy to do that because I don't have this natural sphere or circle, basically. I don't have these natural circles here to just extrude it. So I would, basically have to select something here and form this into a circle. And then I could extrude it. But maybe on this example, let me just disable the wireframe. Maybe on this example, you can see it pretty good that the topology of objects can be very different, although they have the same shape, and the topology can be broken so that you have to repair it by hand or with tools in order to proceed with your project, because sometimes they really can't be overlooked and have to be fixed. And so you can use the topology to shape your objects as you wish if you prepare them in a good way, for example. That's all for this video. Thank you and see you at the next one. Welcome to another video of the Blender modeling course. In this video we will model a small object with some of the modifiers you now know from the videos before. Alright, so we will use some of the modifiers, as I said, and for that we will use some of the generate category here, which you should already know by now. So we want to model a little birdhouse, so a little wooden house for a small bird. And for that, we at first want to model it by hand, and then we will use some modifiers. Okay, so at first let's go to the edit mode and make a loop cut here, and then move this one a bit upwards so that you get this roof triangle shape here. Something like this, maybe not that high. And now you can decide what you want to do. You could either do the roof at first or the front and back side. I think I want to do the front and back side at first. So let's switch to the face selection and select these faces here. Let's enable the X-ray mode to see it better, and then create a small inset like this. And then with E you can extrude these, but you can now just do a right click to leave the extrusion at exactly this position, and then just press S to scale these, and you want to scale them on the Y-axis. And by this you can see you can push both sides at the same time with the same intensity inside of the object. For example, like this. Yeah, this looks fine, I think. And now we can proceed with the roof, since we got this now. Or we don't have to. I think it's better if we just do the boolean now. So now we want to do the boolean cut to make a hole inside here, so a cylinder to cut through the front and back side, that we can create a round hole for the bird. For that, just add a circle and increase the resolution a bit. I will just double it to 64. Then I have my circle here. Then I want to rotate it here by 90 degrees. And then just scale it to the size of the hole. So I think that's enough, like this. And then place it at the right height. Maybe I have to look at it from here. So I think this is okay. And then I can just fill it with F and then extrude it in this direction like this. And so now I got my cylinder here, which I can cut out now. But before I cut it out, I want to make the walls solid, because currently I have a solid object. So I can show you that. If I now do a Boolean cut here, it will look like this. Let me just make this to a wireframe here. Then you can see it. So currently this would be just a pretty thick house, because we have no inside here. And to change that, you just have to add the solidify here. And if you do that before the Boolean, you can have a wall here. So let's disable the Boolean. At first, we want to create the thickness of the walls like this, and then decide which thickness is okay. I think that's all right. Maybe a bit more like this. Yeah, and then after we got the thickness, we want to apply the Boolean cut, and then we got something like this. So we got a thick wall with the cylinder cut out, which makes this round hole. Then we can apply both of these, and then you can delete this one, and then we got something like this. Yeah, so it's a hollow little house. Yeah, that's all right. Then we can come to the roof now. I think I want to extrude it a bit, like this. Extrude it upwards a bit. And then extrude these sides here, E. And then scale it on the x-axis, like this. And then you can position it, a bit here. Maybe you want to do it like this. And then you got your little roof thing here. And then you can extrude, or not extrude, move these border parts here just apart from each other. So you just scale it here on the y-axis, S, Y, and then you can see it. Okay, it's not enough, of course, because it's connected here, and you can just then extrude it. So you just press E to extrude it, then right click to cancel the movement, and then you scale these extruded faces up like this, and then you got your extruded faces here. Yeah, so you have to always take care, like I just saw, you have to pay attention where it's connected, but you spot it very easily, the mistake. So if the other faces or the other points are moving, then it's still connected. So you just have to create an extrusion here for these, overlapping roof things. Okay, or this, roof border. And now the last part would be to create a little, bar here, a little cylinder for the bird to sit on, or the little birds to sit on. And for that, I would just make another Boolean, but with the union, where you can, add geometry from one object to another object. And for that, I would just again create this, circle, rotate it again here on this side. And now I just need to choose the position and scale of it. I want to position it about here, that a bird can sit here, like this, next to the entrance. Okay, so, and to do that, I just have to again fill it and then extrude it. By the way, if you extrude something and you don't know in which direction you have to extrude it, because if I press now E, I can extrude it in both sides, but one side is the wrong side. So my tip is to press E and then just hit a positive number on your keyboard, for example 1. And then I know this is the correct positive side, and just enter and to apply it, and then you can move it again after that. So by this you can always tell that you're on the correct side. Because it's there is a correct and a wrong side when you extrude something. And now you can just hit the face here that you dip into the surface, and then maybe I want to rescale it. It's a bit big. Okay, like this, and then again move that bar like that. Okay, I think that's all right. And now I can just make a Boolean operation on this one, Boolean union, and select this object and then apply it. And now I can hide this bar here. And you can see now it's, it was added to the object here. Yeah, and it's connected to the object, of course, too. You can see that maybe on this point here. So you can see it's connected, but it has double points here. And to fix that, just select everything. Go to Mesh, Merge by distance. So 10 vertices were removed. And now we are basically done. So we got our shape here. Maybe let's change the lighting a bit with here, that you can see it maybe a bit better. All right. So now this is the birdhouse now, with the hollow inside and the little bar here. And now you could, for example, bevel the entrance that it's a bit more soft and doesn't look that hard. I mean, usually if you just cut out the wood, it would be pretty sharp here, but let's just make it a nice little hole. Just select all the vertices of the hole here and here as well. Oh, there is a little mistake, but that's no problem. So you can just select everything here, and then you can just change the perspective and just disable these. And by that you can always, tweak your selections, or like this. So you can just select some parts and then deselect other parts, and by this you can, control your selection. All right, now we got selected these parts. Then I want to switch to edge selection and view it from the top and just deselect the middle parts here. I'm just doing a border selection with B with the middle mouse button. This means deselect, so middle mouse button. So I hold middle mouse button with the border selection. And by this I selected only now the rim of these, or both the rims, the inner and the outer rim of the front and back hole. And now I can just bevel these with Control B, like this, and bevel it a bit. I have to take care that I'm not overshooting it here. So I want to create a bevel like this and a bit round. And then I got my nice hole here for the birds, and the rest of the house looks like this. So this is how you can model very nicely and use some of the modifiers which you learned before. That's all for this video. Thank you and see you at the next one. Welcome to another video of the Blender modeling course. In this video we will model a little and very simple scene with the modifiers you learned in this course before. Alright, so let's get started. At first I want to create a floor, which I will do with just a simple plane. So I delete this cube and add a plane and scale it a bit up in the edit mode like this. After that, I want to create a little wooden fence around it. So for that, I just want to create one part of this wooden fence and then just duplicate it with the array modifier. So for that, I jump to the side view, or the Y view here, -Y, and just create a simple cube, which I want to shape to a part of a fence. So for example, one of these, and just move the top part up a bit like this. And of course it's way too thick, so reduce the thickness. So this would be one part here. And now I want to create a horizontal bar, because if I want to array it now, it would be like this. I mean, this is okay too. We could do something like this too, but I want to add a little more detail with horizontal bars. Alright, so for this I will go to the edit mode to be in this object, and then I just add another cube. Alright, and then I want to scale it down, of course, too, that I get this bar here and place it in front of it basically, and scale it more thinner like this, and then move it right before it. And then you can already see how it gets duplicated here. And then I want to move it a bit up like this and scale it down a bit, and of course make it a bit yeah, shorter, maybe like this, and then just duplicate this part and then move it down a bit like this. And then you have this shape here, yeah, which is yeah, an okay looking fence. For a simple scene, this is all right. And you can, of course, bevel this part, for example, a bit to give it a more soft look. Maybe like this. Yeah, I wouldn't bevel these yeah, edges here, because you can see that yeah, it gets beveled, of course, then at the seaming points here, and then this would look a bit weird. So I would leave it, yeah, like this. Maybe in the end we can bevel the end parts, but that's optional. On this one here, it works perfectly fine with the area modifier. That's why we do it now. Okay, now we can, yeah, position this fence here on our field. I don't have exact values for this. I will just eyeball a bit with my field here, maybe one more. Okay, let's just put it out to 10. So I have 10 copies of it. And then I can just duplicate this whole object, yeah, because of course this is a whole object here. If I can disable the modifier, you can see it's basically just this one part, which, yeah, I multiplied. And then I want to rotate it by on the z-axis by 180 degree. By this, yeah, it will turn like this and will be oriented on the opposite side. And then we can place it here and then just move it a bit up. And this one we can rotate by 90 degree on the z-axis and then place it roughly here. Yeah, maybe something like this. Move it here, rotate on the z-axis by 180. And then we have something like this. And I want to have the cross around here. Yep, that's all right. Doesn't have to be perfect. We will cut these parts anyway. Okay, now I want to, yeah, apply every modifier here because I don't need it anymore. So I can just apply it on everything. You can either do it by clicking on any one, on any object and apply them one by one, or you can just select every object with the modifiers you want to apply, and then you can do a right click and select convert to mesh. They are already meshes, but modified meshes, and when you, yeah, convert a modified mesh into a mesh, the modifiers just get applied. And then it will be like this, and everyone, yeah, will be applied here. And now you can just cut the parts out you don't want. For example, I want to, yeah, delete, of course, these two. And then delete these. And then I maybe have to close these. Okay, there are doubles anyway. Merge by distance. Okay, and now they should be like this. All right, and now we can, yeah, just trim them a bit onto here. And here we can, yeah, just move them a bit back like this. Yeah, and that's all right. And then just the same thing here. Move this a bit on here and move this on here. All right. So we got these two, then we are left with these. Want to delete this. Merge by distance. And then, yeah, just move them back that they don't overlap here. All right. Okay, so now we got our closed fence here. That's okay. And now I want to create, yeah, some simple trees. I will, yeah, leave the leaves. I will leave the leaves because, yeah, just for the simplicity of the scenes, I just want to use the wooden part of these simple trees, yeah. Maybe it gets too complicated then, and yeah, this is supposed to be very simple and to, yeah, be very good at recreating it from this video, and that it shouldn't take extremely long. So that's why I want to yeah, just do the wooden part of the tree, so the branches basically. Alright, so now to continue with the trees, I want to create the general skeleton of the tree basically. And we're going to do this with, yeah, a skin modifier, and for that we need a bit of geometry, for example this plane. And I just want to delete every point except one, because I only want to work with this one point. We'll just move it here a bit over the origin, and then I can move it here. I just want to move it slightly, yeah, under the surface. So this point now is slightly under the surface, which is here. So here you can see the point. And now we are going to add the skin modifier. But at first let's make a simple basic shape here. Something like this. And then it branches off here maybe. Like that. Yeah. And then maybe something like this. Just extrude one point after another. And then you can maybe, because this is very symmetrical here, you can select. By the way, if you want to select one branch here, a easy way would be to just increase the selection. So for example, if you have long branches here, like this, you can just, for example, select this one. And if you then press here, Control plus, you can increase the selection. You see that's how the selection spreads out on the points like a fire. Yeah, so for example, if I have a very subdivided plane here, and I here select one point and press Control plus, you see it just expands. And yeah, we can use this to select one of the branches. For example, I can select the end of a branch and just expand it until I am here. Yeah, and then I can just undo this last one. And then I can reposition this branch, for example. That would be a good way to select it, or just with, the normal selection tools. But here, sometimes it's handy to just select the end, especially if you have many little branches there. Okay, and now we have our, let's say default tree. Yeah, maybe move it on here a bit. All right, and now I want to, make a skin on it, which is basically geometry around these edges. And we can use the generate modifier for that, skin. And now it's very bulky. Just go to the edit mode, select everything, and with Control A, you can choose or change the size of the geometry around it. And I want a bit more small, like this. And on the trunk, let's go to the X-ray mode, select the trunk here, and then just scale this up a bit, and maybe this too. Alright, and now, of course, this is procedural, so you can just, or it's live, and you can just change it, and it will, of course, keep the active modifier. Okay, here you can see something is a bit wrong. That's because sometimes you have to tweak it a bit until the geometry finds its way back on the mesh. You see that, for example, this would be a better position. And then I can apply the subdivision surface modifier to make it a bit more smooth. And then I'm pretty happy with it, I would say. So this is a little almost coconut tree looking thing. And then you can just keep it that way. And for example, we could copy this little tree a couple of times, maybe rotate it a bit. Something like this. Alright, and then you could alternate some of these, for example, move some branches around or add new branches that they look maybe a bit more different, or move the trunk a bit, or create a subdivision here in between them and move that one that's a bit more like this, crooked. And then by this you can make little versions of your tree. Doesn't have to be that elaborate. It's alright now, I think. Just for the example for modeling, this would be enough. So you have some trees, and I would dip them a bit more into the ground because they're looking a bit out here like this. Okay, so now I'm happy with it. And now I want to make the fence here a bit more crooked to make it a bit more dynamic, because currently this is very straight, and just looking upward. I mean, this is how a fence would look like, but yeah, for the modeling example, I want to make it more dynamic a bit. Okay, so to do that, I want to use a deform modifier, for example, the lattice deform, which would be, which would fit into this type of deform I want to do now. Alright, so at first, let's jump to the side view again and add a lattice. And I want to have my, fence inside of the lattice. It should be barely inside, or perfectly fitting like this. That's okay. Okay, so because the influence is the distance to the lattice, and because that's why I want to keep it very close to the lattice border here. But that's alright. And of course on this dimension too. So scale it up a bit and then move it on here. That was a bit too much. And that's okay. So now I have my lattice cage now around my object. And now I want to add the lattice modifier to all the fences. For that I just select every fence and then add a modifier, lattice deform. But take care, only the active fence here has now the lattice deform modifier. Then I want to select the lattice, and now I want to click on copy to select it, which means I copy this modifier to all the other selected fences. And now everyone has it. Okay. And now I can deform my fence with this lattice deform. Let me just increase the lattice resolution a bit on 3, 3, and the height is okay with 2. So now I can, for example, pick this side here and then move it a bit. And you see the lattice deforms the fence in this way, that it just deforms the points relative to the distance of this point here of the lattice itself. And I can already tell I want to change something, because I don't want to change the height of the fence, so the floor here should be the same. And because of that, I just move the lattice a bit inside of the object. So, like this, the little feet of the fence are looking now out of the lattice, and now if I move it, it doesn't get bent that much. Yeah, maybe I want to increase it even more, like this. Okay, I think that's good. Alright, so now let's just bend it a bit. So for example, like this on the outside, and here on this outside. Then I turn my camera and move it here and here, for example. And then you can already see you can bend this fence. Now let me just switch to perspective mode. So now my fence can be bent pretty nicely here in different directions. And by this you can create dynamic shapes here. For example, a little dent in here and so on. Yeah, you can be creative here how your fence should look. And if you want to add more points, you can just increase the resolution on one X, for example. Let's say the U, which is this one. Then you have more points here, and then you can be more let's say you can make like a snake path with the points here if you do things like this and this and this. And then it's a bit more dynamic here, as it would be a bit destroyed or something. Yeah, and by that you can create exactly this fence here. Now you can play around with it, and maybe higher or lower, and on the in and outside and so on. And then you can get nice dynamic shapes out of it. Alright, so I would say this is enough for the fence. Maybe on this side a bit more. Maybe here on the inside or something. Alright, and then I'm fine with it. And you can just keep it as a modifier. But if you want to apply it, of course, you can apply it here, and then it's applied and it's on the geometry now. But currently you can, of course, disable the modifier and can just preview how you distorted the fence. And the last thing I want to do is add some little fruits or decorations or whatever on these trees. Oh, I spotted a little mistake here. So I can see that the geometry is open here. And I want to change that, and I just have to move this point, for example, a bit around until it snaps back here. Yeah, something like this. Okay, now it's open on this side. So maybe, that's okay. Now it's closed. Alright, so you have to take care a bit with a skin modifier. It's a bit broken sometimes. Alright, so let's create a fruit. For that, I will just use a icosphere here and just deform it a bit. For that, I just want to go to select random, then random vertices were selected, and then just scale them up or down a bit. Yeah, like this, and then just, yeah, you can do some things manually too. I think that's okay. So this is my fruit I want to hang on the trees. So scale it down. I want to be something like this maybe. Okay, and then I'm just going to copy it on the trees manually by hand. Yeah, to use this snapping tool here. I want to snap it on the face project and not with the closest, because this is the bounding box closest, so it doesn't really touch the tree because it's a spherical object, and I want to use the center. Okay, and now I can just copy it with Shift D and snap it on one of the branches here. You can see that it snaps on there, and by this you can just duplicate it over and over again on the branches like this, and go on and go on. And by this you can just, or you can of course rescale them on some. And yeah, then you can just position it there, or maybe make it smaller and put more on there, and so on. And then you can just place them manually. It's pretty fast when you do the face snapping thing. Some duplications here, duplicate, 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 and then you're finished. Like this. Alright. Okay, oh, I missed that one. So, and now you have some trees here. With some details on the branches. Let's say there are fruits or something. And you have a nice fence around it, like a little garden, which is a bit crooked and dynamic and broken from the weather or whatever. And now you can model in this garden, or you can of course, let's say you want to change the floor or the ground level, basically. You want to make little dents, and you can of course subdivide this until you have enough details. I think that's okay. And now you can go to the proportional editing here and just move some parts up or down. Like this, little hills or little holes in the ground and so on. Like this, and then you could use a subdivision surface modifier to smooth it a bit. Alright, and then you have a little garden here. Let's disable the overlays. Yeah, now you modeled a little garden with a fence where you can deform it pretty dynamically, with trees where you can at any time change the shape of it, with a skin modifier here like this. So pretty dynamic thing. And a ground where you can of course change it at any time, and little fruits on the tree. So that's your second modeling example scene, little garden with big fence. And I hope you learned something and have fun to recreate this. That's all for this video. Thank you and see you at the next one.